respect yourself. And I feel obliged to add before you wreck yourself. What failed running? Oh yeah, okay. We're just in the process of copy pasting shit. Oh god, I feel so sluggish. It's Monday mornings for you. So okay, if our alpha index of letter is +2, so we have to check whether minus 2 will be less than 0, right? So we can copy this. Let's do that. Let's put these in parentheses just so I can see it better. So -2 will be less than 0. Because if we get letter B, right, and we take out 2, we get -1. So we know we approach the edge of the array. So that means we have to plus 25 to it to go back to the other side. Alright, so then then we do alpha index of letter +2, which will... No, we don't need +2. We need just -25. Wait, no, +25. We need +25, which will bring it back here. Yeah, and then +1 to add the second thing. I think. Okay, and finally, if that doesn't happen, wait, where's my other set of parentheses, curly braces? Where'd you go? What are you matching? Yeah, I'm missing some. Oh, no. Should be here. Alright, so else. Oh. Otherwise, all we have to do is just -2 because we want to move left on the array. So we do -2. Oh, not +1, -1. Yeah, because we want to move left. And I mean, it kind of looks like it. I think we're missing more parentheses somewhere. Oh yeah, top level. Let's do this, and add another one. Alright, well, we can try and test it out. Zestful, thank you for the follow. How are you doing this Monday morning? Where are you from? Are you from morning, afternoon, or evening area? Okay, so we get the cipher, and we just want to console log that bad boy with what? With a call to cipher.decrypt. And all right, let's see, what do we want to decrypt. I'm okay, UK, so it's 6 a.m. But I'm wasted, which is the sad part, because I'm not wasted. I want to keep drinking. I love the playlist. Oh yeah, it's pretty good. I'm warming up to it myself. Previously, we would listen to like lo-fi stuff that wasn't really intrusive in learning. But I'm digging this. I might have to look into more like, what was it? Copyright-free rock. Yuck. I mean, as its purposes. When you just need a little bit of white noise. Oh. Okay, and we are trying to decrypt. Let's build a message. So N Q X and G. So that should return love. Oh, we don't have a return statement. Never mind. Should be here. Yep. Text array. Okay. Oh, there we go. It works. Now, the question is, will it work with the letter jumping from B to Z? So if we add a B... Oh, it returns Z. Okay. Why was this so hard to figure out last week? I'm pretty sure I did the same thing. Oh my god. Was my brain so fried? Let's do A. And it returns Y. Yeah. Let's do with the weird letters that we did. What was it? C? Because C returns A. And it was, I think, T as well. It's problematic. Returns R. And yeah, it works. Holy crap. We got it working. First try on a foggy brain in the Monday morning. Can't believe it. Alright, so now, as per the instructions. Oh, wrong window. We also have to... What is it? Decrypt takes an encrypted message and returns a lowercase string with each letter shifted back in the alphabet based on the set shift value. Right. The difference here is that we have to return lowercase. If you can code on a foggy brain on MB day, you're pretty much hireable. I'm working on it. I'm working on it. I actually got a job offer. Well, sort of, quote unquote job offer. They were like, hey, you seem motivated and interested and capable. How about you plug in these holes that you still have, and then we'll give you a shot. So that's essentially what we're doing here. I'm plugging up holes to become hireable. Well, the easy way would be to just change this to all lowercase, but we probably can do to lowercase here. No? Building in public, aka pretending you know what you're doing. Yep. Wait, what? No. Oh, we didn't pass anything. God damn it. What do you do, Zestful? What's your profession or occupation? Wait, hold up. Do they got a sinking ship which also needs plugged? Who's they? I'm getting a bit lost in your train of thought. Or your comp sci? Oh, that's cool. Oh, people that want to hire. No, I'm pretty sure they're just ramping up their capabilities. I think I read an article about them that said that they want to increase their number of programmers by like 50% or 100% or something by the end of this year. So I think that I'm being recruited as part of that. Cipher, anti-crypt. How is comp sci? I don't know. Like, I quit my job and I had the choice to either go comp sci or just self-learn. And when I looked at the prices of the of essentially going to university, I was like, maybe I'll just self-learn. When's the layoffs are? Yeah. I mean they're doing pretty good in terms of like revenue and all that. I did check out their financial statements and whatnot. So they're profitable. I mean they would have no reason to have layoffs this year. It's lame, but my uni course isn't like the rest. I don't even know what the rest are like, let alone yours. Self-learn plus projects, especially if you're getting attention. Yeah, I mean, it took me like 2 months of job hunting to even land that. So I don't think this exactly classifies as getting attention, but you know, I've sent out like hundreds of or like I've sent out my CV to hundreds of companies, and this is, yeah, I think this is the first interview that I got. Decrypt. What are we decrypting? Whatever, anything. Love. Oh, it's returning lowercase. Cool. I tried to self-learn like 4 years ago before the comp sci route and got some interviews. But like I was jack of all trades myself, a master of nothing, or whatever. What the phrase is. I mean, I feel like there's a place for that in the industry. For a jack of all trades. Because not everybody can be a master of anything. And most people, I feel like that's how they go through learning programming and programming in general. Because you have to try things out before you sort of narrow down and get into a single niche, you know? You can't just be like, oh, one day I'll start programming, and then the next day, oh, look, Python. And then the next day you're like, oh, look, this specific thing about Python, and then build a career out of that. Legit had interviews tell me I had a lot of surface level knowledge, but not what they wanted. Well, then you hit him back with like, what else am I missing? Give me a couple of weeks. I'll brush up on deeper level knowledge. Come back. You guys give me a job. So I figured uni would give me an excuse to buy time and work on my stuff. Yeah, I mean, that's one way. Like, what did they teach you at university? In general, like, I bet a lot of unnecessary stuff, maybe. Fuck off. Okay, so we're getting back lowercase. That's fine. What are other things? Right, we actually, instead of decrementing by the numbers, we have to shift by the shift value here. So this shift value +2 -1. Went to uni on my 3rd year, but done like 6+ years of self-learning. I mean, I feel like you should be plenty ready for some kind of job. It seems like you have a lot of experience. Have you done any big projects? By shift value, and that just is minusing out the index value and doing 25. Okay. So we do the same thing here. Alpha index. If alpha index minus shift value, then we +25 -1. Wait, where does our shift value work into here? Oh, we do shift value -1. This shift value -1. Or otherwise, we just do this dot shift value. You know you're ready. Just gotta prove it in the projects. But my issue is I can't commit to projects. Also, my issue is my girlfriend can't commit to me. Never meant to say that. I mean, obviously I don't know the situation, but you know, the sort of the advice that applies to all cases like that is just, you know, get over it, man. There's plenty of fish in the sea, and if you broke up, there was a reason for it. It's for the better. Trust me. As a person who's been broken up with, like, I don't know, 5, 6 times, and then eventually found the one, trust me on this one. The reason was not necessarily, unless you like cheated or something. In that case, I'm dropping the topic. Okay, so does this still work? Let's do love. Yep, it works. Skill issue plus personality. No, it's not a you issue. It's what most likely it is just or most often what it is the lack of understanding that relationships need a lot of work. It's never gonna be like, oh, this personality and skill issue, quote unquote, is just a perfect match with the other person, and then you have no issues whatever to work through. There's always going to be issues. You're always going to be sacrificing a little here. You're going to have to make compromises there. You're going to have to learn to live with that person, to communicate with that person, and so on. So, communicated to her like she was 403. What? My advice? Oh. Dude, my advice is forget about her. Just move on. Focus on your studies, focus on getting a job. Once you're in a better mental space, like take care of yourself. You know, you don't need uh, a girlfriend to be happy. You know, just be happy with what you have. Start start learning how to be happy. Memeing, by the way. Yeah, I get it. I'm just throwing little tidbits of advice in my foggy state. Once you're happy with yourself, it'll be much easier to be or to find that relationship that will work, and it'll be easier to make it work. Okay, so I think that's about it. Let's see if Codecademy won't be a little bee and will accept this solution. Also, what happens if myself is whom I hate asking for a friend? Codecademy, yuck. It's not yuck. It works. It's nice. It's nice enough. Alright, so the formatting is atrocious, but come on, run. Are you running locally since you're coding locally? No, I am coding locally just because this code area is horrible. But usually I work here. And their servers are also sometimes crazy. Yeah. What? Hello, 5 long live chaos. Twitch scam. I'm just gonna do that. And if you want to say something, I mean, thank you for the follow. But if that seems like spam, if you want to say something human, you're welcome to. Yeah, probably. Wait, what was it? What was I saying? Oh yeah, I was replying. Also, what happens if myself is an idiot whom I hate? That's just something you gotta work on. Try psychotherapy. It helped for me. It's just negative talk, you know. You're focusing too much on your negatives, and not allowing any positives. Codecademy sponsor inbound. I wish, man. Okay, so it tested decrypt A with shift 1, expected Z. And what did you get? Oh, gotta do the initiation thing. Wait, there we go. So A. Got a W? What? Oh, with 1. Got an X. That makes sense. So we were on A. I tested it before it worked. The hell? So A minus 1. So 0 minus 1. We got a minus 1. We fell into this bracket. We added 25 to it. Oh, we got 24. That's the problem. We got 24 and then we minus out 1 out of that. And then minus 1 out of... Okay. So the problem was that we also have to reset... wait. Shit. We have to reset the alpha index. But what do we reset it to? Starting value? Wait, no, this don't make sense. We don't change it really. We're just checking for it. So it's 0 plus 25. That puts it here. Minus 1. Alright, we don't need to do the indexing thing. Because we're working backwards. Wait, but still, we're supposed to get Z. I mean, we're getting closer, but... Wait, if we have... No, that's just gonna mess up the indexing. If we just add 25, we still have to minus out shift value. Alright, what happens if we get a B? The index is at 1. So we add 25 to it, we get 26. And we minus out 1, get 25. That's fine. When we have A, we already have 0. So that's not less than 0. So plus 25, we get 25. So should we do 26? I mean, we'll get the Z, but will it work with the other letters? What if we do B? We get A. Oh, yeah, makes sense. What if we do the cipher to 2? Z. I guess it works. So, I think this is the only change, really. Holy crap, this is so smushed. 25. Right, this is the decrypt. Plus 0, plus 25. So do we do plus 26? Oh, 26. And we also minus out this dot shift value. Oh, crap. Right? Okay. Garbage of a person. Codecademy. There we go. Tested method A, B, C, D, E, F, G with shift of 25. Expected B, C, D, E, F, G. Swear to God. A, B, C, D, E, F, G. I got Y, Z, A, B, C, D, E. What? Oh, shift of 25. H? Huh? A turned into H? How? So we had A. That's 0. Plus 26. Minus 25. No. Yeah. Plus 26 minus 25. We got left with 1. So it should have been B. But it turned to H somehow? What? Wait a second, the index that we're getting, index of, it's always gonna be less minus 1. So we could do plus 1 to get the actual number, because we're accounting for the indexes down here. Wait. Alphabet dot index of plus 1. Sure, let's do plus 1. Try it. Gotta try something. AC. What? How are we getting more letters out than we got in? This doesn't make sense. Text array. A, B, C, D, E, F, G. Okay. Where the hell does the problem occur? Are we getting correct indexes is the question now. So 1 1 is for A, 2 2 2 3 for B. So the alpha index of letter is wrong. Oh yeah, and then it exponentially goes insane. So we got 1 in text, 1 in then 2. I guess we don't need this here. 0 0. 0, 0, 0, 1, 0, 2. What? How do we have an extra goddamn letter? That's 7. 1, 2, 3, 4, 5, 6. No, we don't. It's just that our A turned into H somehow. 26. 26. What about 25? Right, so it didn't decrypt anything. Or did it? No, but yeah, it should have been 25. Because now our indexing looks proper instead of before. But this didn't work either. Yeah, it was a problem with the 1. So is this just a case of adding another if statement? Just if shift value is just 1, all we really have to do right, so if shift value is just 1, we just add 25 minus shift value. Yeah. And that should work. But instead, for whatever reason, it returns us 1 more. Okay, I guess, sure, let's do it. I'm getting tired of this goddamn problem. Alright. Else if... Wait, no, not like this. Else if shift this dot shift value is equal to 1. Ah, but now our alpha index minus shift value. No, it shouldn't. Let's check. It probably hits this one. Yeah. But why? We have a... Oh, yeah, okay. Could switch them places. So it hits the shift value check first. Alright, let's do it. So we take this out, put that here. Take this out, put that here. Switch that. Now we have to switch this. Take this out, put that here. Take this out, put that here. Oh. Plus A. The hell? When did this become plus A? From the get-go. Interesting. Plus 25. Sure, let's do 25. Yeah. There, put that here. Put that here. Then do a switcheroo here as well. Right. 25, this should probably be 24. And so we're hitting the shift value check first, and then we're hitting the warp check. And then we're doing that. Okay. How is it still Y? It's just 25 then? Yeah. Holy crap. This freaking exercise is burning a hole in my brain. What the... Alright, now it's not happy with something else. Or at least we're moving forward. X, Y, Z. A, B, C, D. With shift cipher of 3. Okay. We're getting nonsense. So X should become U. The hell you mean? Oh wait, no. A, B, C, D, E, F, G. A returns W. X, Y. So A returns W. What? It should move 3. Should return 2. Should return Y. Or X. So 24? I don't know. Now it's V. Shit. 26? No, now it's no. X, Y, Z. A, B, C, D. Okay, let's try. I'm not gonna mess around with this anymore. This doesn't work and it probably won't work. We're just looking up the solution and we're being done with it. Yep. Okay. Spent way too much time. Let's take a look at their solution. So... Oh. Okay, so... Oh, right. Yeah, they're doing it with Unicode. Right, we looked at this last week. I completely forgot that you're supposed to do it with Unicode. I mean, you probably can do it with indexing, but it's just so much harder. Yeah, but with Unicode, you can just directly go with the numbers, and that's pretty much it. Alright. Okay, you know, whatever. We try to make our way work. It didn't work. Let's shelf it. And let's move on. Holy crap. That was a long time for that exercise. Alright, so the goal of this unit was to understand intermediate JavaScript concepts such as classes and modules. Knowing these concepts should improve your ability to write JavaScript programs and prepare you for creating web applications. Having completed this unit, we are now able to create classes in JavaScript, implement JavaScript modules, create JavaScript errors, and handle them. If you're interested in learning more about the topics, here are some additional resources. Alright, so we have design patterns. Alright, this is an interesting read. Let's favorite this. We'll read it later. Reducing complexity with guard clauses in PHP and JavaScript. The hell's a guard clause? Alright. Documentations, inheritance, and prototype chain. In programming, passing down characteristics in JavaScript is a bit confusing for developers experienced in class-based languages, Java or C++, as it is dynamic and does not have static types. While this confusion is often considered to be one of the JavaScript weaknesses, the prototypal inheritance mode itself, in fact, more powerful than the classic model. Fairly trivial to build a classic model on top of the prototypal model, which is how classes are implemented. Okay, this is a bunch of jumboree that we don't need right now. Alright, let's move on. So, okay, we're done with JavaScript syntax. We can cross that out of off of our list. And we're jumping into database basics. Okay. Before that, however, well, let's hop into the course material. Where is it? Working with databases. There. Alright, before we do that, we're going to take a little break. 10 minutes as usual, nothing fancy. And I'll see you guys after the break. Oh crap. The webcam overlay's broken a little bit. No, it's not. Hold on. Just, panic. Okay, we got it. Alright, see you in 10. Done. I guess I know enough syntax to get through places. Alright, so databases. So what will we be learning? The goal of this unit is to learn how to create tables, retrieve and update data in SQL databases, and build a data-intensive web app. After this unit, you'll be able to create, update, and delete data in SQL database, write SQL queries, perform SQL calculations, and work with multiple tables. You'll put all this knowledge into practice with an upcoming portfolio project. You can complete the portfolio project either in parallel with or after taking the prerequisite content. Alright, let's move on. So, what can I do with the database? You can do with databases will ultimately help you design your own. With what you can do. Alright, let's say you're working at a company that already has a database created for you. In this section, we'll learn how to write queries to pull relevant information out of that database. Becoming familiar with what you can do with databases will ultimately help you design your own. You need an understanding of how people use databases in order to create effective ones. You'll learn about general queries, aggregate functions, and how to work with multiple tables of a database. Let's get started. Alright, so it's gonna start with basic queries. I'm a little bit familiar with those, so it shouldn't be too difficult. So in this lesson, we'll be learning different SQL commands to query a single table in database. One of the core purposes of SQL language is to retrieve information stored in a database. This is commonly referred to as querying. Queries allow us to communicate with the database by asking questions and returning a result set with data relevant to the question. We will be querying a database with one table named movies. Let's get started. A fun fact, IBM started out SQL as SQL, Structured English Query Language, in 1970 to query databases. Alright, so we should get acquainted with the movies table. So we select all. Select, I said, from movies. Oh. There we go. Got a bunch of movies. ID int, year int, IMDb rating, real. What is real? Alright, so we got name, genre, year, IMDb rating. Okay. Select. Previously, we learned that select is used every time you want to query data from a database, and star means all columns. Suppose we are only interested in two of the columns. We can select individual columns by their names. So to make it easier to read, we moved from to another line. Line breaks don't mean anything specific in SQL. We could write this entire query in one line. It would run just fine. Alright, so let's select the name and the genre columns of the table. So select name, genre, from movies. There we go. Now we want to include a third column, year. here. There we go. Why is it lit up differently? I don't know. We'll just roll with it. Next, as. Oh, we can change the thing. Right. Knowing how select works, suppose we have code below. Select name as titles for movies. Right, so we just change the return column name. Although it's not always necessary, it is considered best practice to surround your aliases with single quotes. Note that this practice is specific to SQLite, the RD relational databases used in this exercise. When you work with other relational databases, notably PostgreSQL, no quotes or double quotes may be required in place of single quotes. All right. When using as, the columns are not being renamed in the table. The aliases only appear in the result. Check him! He is back. The man, the myth, the legend. Welcome to the stream. Another week of programming is ahead of us. We finished. How's it going? We finished the project barely. I couldn't get the cipher to work properly. So I went F it and we moved on. And the way they did it with ASCII codes as well. So I guess that's the way it should have been done. But we're jumping into databases now. So how are you doing? How is your Monday so far? How was your weekend, too? Alright, to show what the as keyword does, select name column and rename it with an alias of your choosing. Sure. Select name as title. Sure, we can add it to title from movies. Edit the query so that instead of selecting and renaming the name column, select the IMDb rating and rename it as IMDb. I guess we can just do it with a comma. IMDb rating as IMDb. It don't work like that. Maybe we don't need the comma here? No, we don't. Type the statement in the code editor. I did. I guess we just need to do the rating and not the name anymore. Yep. Okay. Also, no point getting stuck for days on that kind of exercise. Yeah, I mean, that's my logic as well. I was like, just, it's been too long. We've spent too much time on this. Let's just move on. Kind of sad because I didn't work as much as I was supposed to. It's fine. You'll catch up. You can't get like attached to, what am I trying to say? Holy crap, my brain is dead this morning. You can't get attached to this mindset of like, oh, I want to do this, you know? Because you can't always get what you want. It makes sense. I mean, and it's true. Because I used to get stuck on the same thing, you know? When I started self-learning, I was like, okay, I'm gonna sit down, I'm gonna do 8 hours of programming with no breaks, I'm gonna knock this thing out of the park, I'm gonna, yeah, and then, you know, whatever happens, you're just tired and your brain doesn't work the way it's supposed to, or something, and you don't achieve that idea that you were supposed to achieve, and you feel sad about it, and then what? There's no point, you know. It's just one day. You'll do better tomorrow. You'll do better the day after. You'll do better next week. It's a journey. It's a marathon, not a sprint. I don't mind coding, but when I start a next project, I have to do like 300 lines of CSS, my brain shut off. Well, take a break, do something else. Unless it's for work, then don't take a break. Just get through it, little bit by little bit. Take small breaks in between, you know. Distinct. When we are examining data in a table, it can be helpful to know what distinct values exist in a particular column. Distinct is used to return unique values in the output. It filters out all duplicate values in the specified columns. Alright, so for instance, selects tools from inventory. Sure. By adding distinct, alright, so select distinct tools. Alright, so select distinct genre from movies. Honestly, I feel like I've been drinking the entire weekend because I'm just so like I literally feel like I have a hangover. I'm close to a headache. My brain's foggy. It's like I've been downing, I don't know, Jack Daniels bottles for the entire weekend. Oh, stop pressing Control S, please. There we go. And I didn't really do that much. All we did was go to the beach and then a dog park. Palms are sweaty, mom's spaghetti, yeah. Vomit on my sweater already. Alright, we can restrict our query results using the where in order to obtain only the information we want. Following this format, the statement below filters the results set to only include top-related movies. IMDb ratings greater than 8. Alright, so where clause filters the results set to only include rows where the following conditions are true. IMDb rating is the condition. Here, only rows with a value greater than 8 will be returned. Operators create a condition that can be evaluated as either true or false. So we have all the same operators that we normally do. Okay. So suppose we want to take a peek at all the not so well received movies in the database. Alright, so select all from movies where. Yes? Are you offering me water? Yes, I will take some water. Wait a sec, guys. My girlfriend's home today, so expect some noises or a little bit of interruption going on, but it's fine. She brought me a nice fresh glass of water with some ice. That should perk me up a little bit. Oh my god, that's a godsend. Thank you. Oh. The dog is going crazy. He was dead when we came back from the beach. Like, genuinely. He just plopped down and didn't move for a couple of hours. Alright, suppose... right, so where IMDb rating is less than 5. Stop pressing Control S, please. Right, there we go. So, okay, what's not popular? Alvin and the Chipmunks, The Squeakquel, The Haunting Scooby-Doo, Anaconda. Man, I thought it was pretty good. All the Twilight movies are, well, okay, not all of them. Eclipse, New Moon, and Breaking Dawn Part 1. Horrible ratings. Oh, glad about this one though. That 50 Shades of Grey isn't doing too well. Now retrieve all recent movies, specifically those that were released after 214. Alright, where year is greater than 214. What do we got here? Jurassic World, Avengers, Ultron, Furious 7, Inside Out, Minions, Cinderella, 50 Shades of Grey. Best one in here is the Star Wars. Force Awakens. What the hell is Ali Wong Baby Cobra? Or The Big Sick? The Big Sick. Like can be a useful operator when you want to compare similar values. The movies table contains 2 films with similar titles, 7 and 7. How could we select all movies that starts with SE and end with EN and have exactly one character in the middle? Alright, so like is essentially for rejecting, whatever. So the underscore means you can substitute any individual character here without breaking the pattern. The name 7 and 7 both match this pattern. Alright, so select all. Didn't know we had to use actual SQL with SQLite or Postgres. Well, with SQLite, yes. With Postgres, I don't know. From movies, where name like okay. The percentage sign is another wildcard character that can be used with like. The statement below filters the results set to only include movies with names that begin with the letter A. Alright. So underscore is probably singular letter. The percentage sign is probably just whatever afterwards. Yeah. Alright, so I wish they didn't really give you the answer here and just tell you like, okay, find out how many movie titles contain the word man. But I guess it's just the beginning. They're taking it easy on me. Select all from movies where name. Do I need to type in capitals? Can I just do select all from movies where name like man? Will this work? Yeah, it does. Okay, so we don't have to capitalize it. That's pretty good. Because it's a little bit annoying. That's what I don't like with these courses. same with mine about TS plus React. The guy's like, do this, but the answer is displayed. Yeah. Well, I assume it's just like the beginning. That's why they give it to you. You know, just in case. But there's other ways to do it. Just put it in the hints. Like, just put it here. Just let me use my brain for 5 minutes. Yeah, exactly. Let's try one more. Edit the query so that it selects all the information about the movie titles that begin with the word the. All right, so movie titles. So word title is the or the. You might need a space in there. Probably will. All right. That didn't return anything. So maybe we don't need a space in here. Huh. Wait, it's not a title. It's not titles, right? I think it's something else. It's name. Right. Yeah, there we go. Actually, we do need a space. Well, no, we don't really. But I think, yeah, they... it's like, you might need the space in there, and it gives me all the results nonetheless. But they're like, nope, we won't accept it without the space. Alright. By this point in the lesson, you might have noticed that there are a few missing values in the movies. In the movies table. More often than not, the data you encounter will have missing values. Unknown values are indicated by null. It is not possible to test for null values with comparison operators such as equal and not equal. Instead, we will have to use these operators, is null and is not null. There is that course, probably the greatest I've ever found, that actually did not give you the answers at all. Goes from 0 to full stack. Planning to redo it after the project I'm on. Oh, crap. Okay, let me take a look. But probably we're not going to do it because now we're not really doing like a full stack. More like these specific things that I need to learn for the job. But yeah, let me take a look. Full stack open. Is there a about the course? Is worth 5 to 14 credits. Wow. Full stack course. The content is the same as the full stack course held at the Department of Computer Science at the University of Helsinki. Interesting. There's also an associated project that is worth 1 to 10 credits. Ah. That's cool. So we have fundamental web apps, introduction to React, communicating with servers. I mean, if they have databases, we might jump onto here. Programming a server with Node.js, testing for server administration, text React apps, advanced state management, React router, GraphQL, TypeScript, React Native, CI/CD, containers, using relational databases. SQLize, join tables and queries, migration, many-to-many relationships. But this is no SQL database. I kind of need the SQL. It's for Helsinki University students, but whoever can do it. They use Postgres in that part. Oh, we will focus on using the database Postgres, which is the #1 in the open source world. Okay. I don't know what I'm looking at, to be honest. There seems to be a lot of information. Exercises for every white parts, which is great. Okay. Exercise. Transform your application to a web application that supports the following operations. Get, post, delete. Exercise. On the command line, create a blogs table for the application with the following columns. ID, author. You either make it work using your actual brain or good luck. We might jump into something like that later on. But I suppose for now I'm gonna actually I'm gonna favorite this so I have it on hand. But for now let's go through Codecademy, brush up on our basics. Then we're probably gonna jump into more serious exercises either on that web page or place like exorcism or something. Because I feel like I do need to really cement in the knowledge of databases. Alright. So is null, is not null. Okay, now let's do the opposite. Write a query to find all the movies without an IMDb rating. Select only the name column. What? Oh. So select name. Oh, wait, select all from name where IMDb rating is null. No. Oh, from movies. From movies. IMDb rating. No, right. Select name, not select all name. It's completely fine following the Codecademy course first, yeah. Yeah, I just want to do it because I have to freshen up my basics knowledge. It's been a while since I worked with SQL. So going through this first, then jumping into more complex stuff, I think that's my preferred way of doing it. The between operators used in a where clause to filter the results set within a certain range, accepts two values that are either numbers, text, or dates. For example, this statement filters the result set to only include the movies with years from 1990 up to and including 1999. Alright, let's do it. Use between operator with a query that selects all information about movies whose name begins with letters D, E, F. Alright, so select. We need all the information about movies, so select all from movies where name between A and no, not A. B. No. Change the upper bound. Is it not included? It says it's including 1999. But what if we do G? Okay, how come? Oh. Wait, what? When the values are text, between filters, the result set for within the alphabetical range. Okay. So in this statement, between filters will result the result set only to include movies with names that begin with it. Okay. However, if a movie has a name simply J, it would actually match. This is because between goes up to the second value. What? Up to J. So the movie name J would be included in the result set, but not Jaws. Oh. Okay, second up to the second value. Yeah, but it still doesn't explain why the between statement includes the second value for numbers, but not for letters. Using the between operator, write a new query that selects all information about movies that were released in the 1970s. So we do between all the movies where year is between 1970 and 1979. Cool beans. And sometimes we want to combine multiple conditions in a where clause to make the result set more specific and useful. One way of doing this is to use the AND operator. Here we use the AND operator to only return 90s romance movies. Okay. So... okay. So it's like a code block. The first condition, genre romance, is the second condition, and combines the two conditions. In the previous exercise, we retrieved every movie released in the 1970s. Now let's retrieve every movie released in the 70s that is also well received. Alright, so above 8 item DB rating. So select all from movies where year between 1970 and 1979 and IMDb ranting. You could call it that. You could call ratings just rantings. Rating is higher than 8. Select. Alright, there we go. So what was it? It was Star Wars and Jaws. Yep. That checks out. Select. Is that an actual word? Select. No. Okay. Remove the previous query. Suppose we have a picky friend who only wants to watch horror films. Using AND, write a query that selects all movies made prior to 1985 that are also in the horror genre. Okay. So we do where year is less than 1989, 85 actually, and the genre is horror. And genre horror. No, we probably need clauses here. Horror. This work? No. Is horror? Yeah. So Dawn of the Dead, great movie. Amityville Horror, great movie. Jaws 2, great movie. Gremlins, great movie. Jaws 2 wasn't that well received, it seems. Only 5.7 on IMDb. Okay, so we had and, now we have or. Similar to and, the or operator can also be used to combine multiple conditions in where. But there's a fundamental difference. The and operator displays a row of all conditions that are true. Or operator displays a row if any condition is true. Oh. So it's okay, it works the same way. It's either one. Yeah, second condition or combines the conditions. With or if any of the conditions are true, then the row is added to the result. All right, so we are selecting all from movies where year is greater than 2014 or the genre equals action. Okay, cool. Suppose we're in the mood for a good laugh or a good cry. Using or, write a query that returns all movies that are either romance or comedy. So where genre, can we do is where genre is instead of equal? Is there a difference? Where genre is comedy or genre is romance. Wait, did I see Shrek? Yeah, Shrek is... Oh, yeah, okay. Shrek is comedy? Well, yes, but it's more like a animated movie. Shrek. Good old Shrek. Order by. That's it with where and its operators. Moving on. It is often useful to list the data in our results set in a particular order. We can sort the results by using order by, either alphabetically or numerically. Sorting the results often makes the data more useful and easier to analyze. For example, if we want to sort everything by the movie's title from A through Z, order by name. Okay. Sometimes we want to sort things in descending order. So order by year desk. Descending or ascending keyword, okay. The column that we order by doesn't even have to be the one of the columns that we're displaying. Oh, that's interesting. Order by always goes after where. Okay. So suppose we want to retrieve the name and year columns of all movies. Order by their name alphabetically. Sure, so select name, year from movies. Order by name. Okay. 3 Men and a Baby. It's a decent movie. Decent comedy. Your turn. Remove the previous query. Done. Write a new query that retrieves the name, year, and IMDb rating columns of all the movies ordered highest to lowest by their rating. Sure. Select name, year, and IMDb rating from movies. Order by highest to lowest. So IMDb rating descending. Correct? Correct! The Dark Knight as a 9. Interesting. And the lowest one is 50 Shades of Grey. Oh, I'm so happy about that. Okay. Limit. Oh, this is just gonna limit the return. Most SQL tables contain hundreds of thousands of records. In those situations, it becomes important to cap the number of rows in the result. Okay. Limit is a clause that lets you specify the maximum number of rows the result set will have. This saves space upon your screen and makes your queries run faster. Here we specify that the result can't have more than 10 rows. Limit always goes at the very end of the query. Also, it's not supported in all SQL databases. Okay, so combining your knowledge of limit and order by, write a query that returns top 3 highest ranked movies. Select all the columns. Alright. Select all from movies where IMDb rating or there's probably another way to do it where IMDb rating. Sure, we could do this like higher than, I don't know, 8. And then we order by IMDb rating. Well, we don't really need the where at all, really. But let's do descending and limit 3. Yeah, it gave us the thing. Case. The case statement allows us to create different outputs, usually in the select statement. It is SQL's way of handling if-then logic. Suppose we want to condense the ratings in the movie to 3 levels. If the rating's above 8, then it's fantastic. If the rating's above 6, then it's poorly received. Else avoid at all costs. Okay. So each when tests a condition, and the following then gives us the string if the condition is true. The else gives us a string if all the above conditions are false. The case statement must end with end. End as review. Okay. I don't think I've encountered the when or the case stuff in my bootcamp. In the result, you have to scroll right because the column name is very long. To shorten it, we can rename the column to review using as. Okay. Alright, so let's try one on our own. So select name. And we do case when second column that is chill if genre equals romance. So when genre equals romance, then chill. When genre equals comedy, then we also chill. Else intense. Okay. And then we do end rename the whole case statement to mood using as. So end as mood from movies. Holy crap, this is a lot of... It's a big old statement. Did I misspell something? When, then, case. Does indenting matter? No, I don't think so. When genre equals, or we do is. No. Turns everything, well, no, it kind of did what it was supposed to do, no? So it has intense, chill, and intense. Is this the case of Codecademy not being happy again? Yeah, they're not happy I didn't use capitalize, even though they were before they were fine with it. Yes. Yeah. Okay, like, make up your mind, Codecademy. Either I can or cannot use capitalized. It's gonna return the same thing, isn't it? Yep. Okay. Well. Review. So, we've learned all the basic ones. But we're gonna move on. Oh, we have a quiz. Alright. What is limit? A clause that lets you specify the maximum number of columns in the result set will have. Wait, what? Oh, columns. Never mind. Can't read. What is like? It's on Facebook, you know. You put a like on Facebook. A special operator that can be used with the where clause to search for a pattern. Yep. What is order by? Sorts results. Pause the sort the results set alphabetically or numerically. Yeah. What does the wildcard character percentage in the following SQL statement do? So it selects everything from sports where the name is something something ball. Sports that matches all sports that end with ball. Yeah. What code would you add to this query to place the colors in reverse alphabetical order? Z to A by name. So order by name ascending. Oh, descending. Wait. From Z to A. By name. Shouldn't that be ascending? Oh, Z to A. Okay. Alright, never mind. Blame my brain, my Monday brain. Which operator would you use to query values that meet all conditions in a where clause? So, and like special operator could search for a pattern. Yeah. Find the error in this code. Select name case does not end with end. Which of the following is not a comparison operator in SQL? This one. What is order by? Operator used with the where clause, sure. Sorts results. Oh. How would you query all of the unique genres from the books table? All of the unique genres. So select distinct genres from books. Yeah. Nope. What is the correct syntax to query both the name and date columns from a database? So select name date with a comma in between. What is the wildcard character percentage? Do in the following scale statement. It returns everything that ends with ball. Is null condition returns true if the field has no value. And by no value, I mean null and not just like 0 or empty, because there's a difference as far as I know. Like there's different, like 0 is still a number, so that's fine. But also a blank cell does not equal null. It just equals blank. So true, I guess. Yeah. What is limit? Clause that restricts your query results in order to obtain only the information we want. Clause that lets you specify the number of columns. No, we rows. Yeah. What is the correct syntax? What is the correct query to select only the cities with temperature less than 35? Only the cities with temperature. So select everything from cities where temperature is less than 35. There. What code would you add to this query to place the colors in reverse alphabetical order, so order by name descending? Okay, cool. Alright, so we have a project. Yeah, project. So we'll jump into this. But before we do that, let's take a little break. As per usual, we'll be back in 10 minutes. All right. We're back. Got me some coffee. Ate a tasty meal made by a lovely girlfriend. Huh? Stop flexing? Okay, I'll stop flexing. My ugly, disgusting girlfriend. All right. We can jump back into SQL. Give me a sec here. All right. So, New York restaurants. We have to put together a table of restaurants called Nom Nom. And we need your help to answer some questions. Oh, they have put together. I did. Use SQL commands you just learned to find the best diner spots in the city. The schema available here. Alright. Pretty standard. We have health, price, review, cuisine, neighborhood, and name. What I would also like to have is probably data types. Health inspection grade. So there's probably going to be integer, price range. Likely an integer as well. Or not an integer, but string. String as well. User review, probably an integer, cuisine type string, neighborhood name string. Okay. Let's keep this open. Just for reference. So let's take a look. Let's move the coffee so I don't spill it all over myself. And then scream in a high-pitched noise like a baby when my pants are on fire. Also take a sip of water. All right, so let's take a look at the table. Select all from num. Oh, so we have dollar signs instead of the price range. The review is the decimal. Health is a letter. Okay. Steak, Brooklyn. Cuisine, steak. It's not entirely cuisine, but... Okay. So, what are the distinct neighborhoods? So, select distinct... distinct. Neighborhood. I hope I didn't misspell neighborhood. We can copy paste this. Probably did misspell it. Select distinct neighborhood from num num. Alright, so Brooklyn, Midtown, Chinatown, Uptown, Queens, and Downtown. Cuisine types. Distinct cuisine. Say Korean, pizza, Italian, Japanese, American, Mediterranean, Italian, soul food, Mexican. Alright, suppose we would like some Chinese takeout. What are our options? Let's again go back to selecting everything. So Chinese. Alright, so select all from num num, where cuisine is Chinese. There's no expensive Chinese places, seems like. Most of them in Chinatown. Have some in downtown. Queens, Midtown, and Brooklyn. Sonny Boys. That does not sound Chinese. It sounds Italian. Sonny! Hey, Sonny! Come here, Sonny! Return all restaurants with reviews of 4 and above. Like, all Chinese restaurants or all restaurants in general? Because we can do both. We can do and review is above 3.9. Yeah. Or we can just do where review is greater than 3.9. Alright, decent bunch. Maria is the highest priced one. Also, Peter Luger's Steakhouse. Are these actual, like, places? Peter Luger Steakhouse. Let's take a look. Peter Luger Steakhouse. Oh, it is, yeah. The website could use some work. Check them. You can write to them. Be like, yo, saw you guys are a pretty expensive place, but your website kind of sucks. Let me do some work for you. Meat packages. Meat. Okay. Suppose Abby and whoever pays I do. Yeah, you know. Or build like a demo for their website and send it to them and be like, yo, your website could look like this. Give me $2,000. I'll make it look like this. I mean, and they're at their scale, 2K is probably pocket change. If they're popular. Not even waking up for 2K? What? God damn. Mr. Moneybags here. What are the rates for, like, I don't know how to classify a website. For like your typical website, I guess. They're the Chinese, not me. No, they're not Chinese. They're in Brooklyn. They're selling steaks. they're probably Italian. Wait, are they? Brooklyn and selling steaks. They gotta be. Peter Luger Steakhouse. How big the website? But in the US, let's see, about our story. When Karl Luger's Cafe, Billiards and Bowling Alley was opened in 1887, the restaurant quickly became a neighborhood favorite in predominantly German Williamsburg. Oh, so he's German. It's not the only thing in the small Brooklyn neighborhood with the opening of Williams Bridge, blah, blah, blah. Karl Luger. Luger. Sounds German. But in the US, 2K is less than what a McDonald's worker does. Well, okay, yeah. I guess if you look at it through the US prism, expect at least 60K in a year in the US minimum. I mean, sure, if you're working for a company, but if you're doing freelance, how much would a single typical website cost? Peter Luger. Who's Peter Luger? Peter Luger. No, not Steakhouse, just Peter Luger. So Frederick Luger. Oh, that's definitely German. Freelance doesn't mean working for free. Also, it's hard to define typical. Yeah, I know freelance doesn't mean working for free. Just because there's free in there. I don't know, like typical, like nothing too fancy, you know, like I don't know. 15 pages, responsive-ish design. Nothing too crazy. "15 pages alone." Is that too much? I mean, it's probably what this place has. Like, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sure, 15, 16. It's probably no more than 20 here. It's like 2 to 3 months work. I mean, sure, yeah. I'm not saying it's like easy and made with a snap of a finger, but you know, like, okay, so 2-3 months of work. What's the average salary for a programmer in US? In the US, I'd ask for 20K. It seems like on the low side, no? Or maybe it is. It isn't. I mean, so if I remember my searches of jobs, of remote jobs in the US, like typical rate is like somewhere from 80, like 90K a year for a junior. Well, let's say like 100K divided by 12, that's 8.3. So times 3, it's 25K. Also, I'd give them WordPress website, just cause. You know, or you could build a demo and then be like, yo, give me 50K and I'll give you a masterpiece of a website. And then in like 4 months. And then you have a job for 4 months that you can do. And you already have like a bunch of money. I dance for them for 50K. Well, you'd probably have to by then. I don't know. I always wondered, does that tactic work? You know, like just going online and just finding a website that's like obviously doing well, but they still have an outdated website, and you just make a little demo for them and send it to them and be like, "Yo, I can make this look good. Just pay me." Suppose Abby and Lana want to have a fancy dinner date. Return all restaurants that are Italian and quite expensive. Okay, so select from noun one where cuisine is Italian and price is dollar bill, y'all. Okay. It's probably viable for a moment, but working for a dev agency might make you step up way more. I mean, yeah, makes sense. Could make your own dev agency. And then you don't have to do anything. Rebuilding the shitty websites is fine for side projects. Yeah? Why not full-on projects? Your coworker, they can't remember the exact name of a restaurant he went, but he knows it contains the word meatball in it. Can you find it using the query? Sure. Now I just have to remember how to use the like operator. Where name like anything meatball anything. The meatball shop in downtown. Alright. Let's let's order delivery to the house. Find all the close spots in Midtown, Downtown, or Chinatown. Alright. Where neighborhood. Where neighborhood is Midtown or downtown. Can we just do or again here? Or China town. No. Return only Midtown. These websites are boring. It's mostly front, which I don't like much. Already struggling with my very little app interface right now. Well, you know what they say, you have to focus on your weak spots. So maybe brushing up on the front end would make you not hate it so much later down the road. You know, just some food for thought. Being more comfortable with something makes you hate it less. Oh yeah, the camera. Wait, so we didn't do that. Our neighborhood is Midtown or Downtown or Chinatown. Do we even have any downtown? Yeah, probably do. Of course we do. Do we need to do like or neighborhood is downtown or neighborhood is Chinatown? Is that the case? Oh yeah, it is. Okay. Find all the health grade pending results. grade pending restaurants. Empty values. So I assume null, where health is null. Yeah, don't go to these places, guys. Los Hermanos, Lighthouse, Jacob's Pickles. What? That's true, but even when I was comfortable with CSS, I still hated it. Okay. Well. Can't love everything. Create top 10 restaurants ranking based on reviews. Alright, so select all from nom nom where review is greater than. No, we don't need where. We just need order by review descending and limit to 10. Think so. So 4.6 seems to be the highest, and if we select everything, take a look. Yeah, 4.6 seems to be the highest. Okay. Use case statement to change the rating system to extraordinary is excellent, good, fair, everything else is poor. Select from nom nom case where review. Wait, is it where? No, I forgot how to use case. SQL case. Oh, it is when. When then? It's not where, it's when. When review is greater than 4.5, then extraordinary. Gonna copy paste this. When it is higher than 4, then it is excellent.
Alright, you ready? Yeah. Alright, let's fucking do this.
When it is higher than 3, do good. 2 is fair. I wouldn't mess with 2 if I was me, and I am me, so don't mess with fair. Because if they're fair during health inspections, or during, well, okay. Oh, it's reviews, never mind. You can mess with fair. And everything else is poor. So you just do else. Else. Result. Ah, okay. So, 4. Right, and then we do end. And rename the new column. Wait, how do we do that? As, right, and as preferability. I don't know. Okay, we didn't get anything. Oh, we need to do from after. Right, I have to remember that. Oh, still doesn't work. Select we're selecting everything, and then we're doing case, then when, then else this, and as quantity text for more details. I don't know, I seem to be doing it correctly. Case, one condition, comes after select, before from num num, else for review 2, unless these are strings. Yes? Yes. But I don't think it is strings. But no, it's not strings. Right, select all from num num. Let's take a look at review. Review. It's probably not the end statement that's messing us up either. But we can comment it out. Well, now it's not going to return anything because the end statement is gone. What if we do this? Still nothing. Okay. Could it be the indentation? Probably not. No. Let's take a look at the hint. I mean, we're doing the same thing, unless it's the name thing. No. So, okay, let's rewrite this entirely in capitalized letters. Case. Maybe that's the problem. Though it seems weird that that might be the problem, where it works everywhere else. No. Oh. Ah. When review is greater. Oh, we're still doing strings here. Nope, still don't work. What is different then? When, else, for, and as, review, or whatever, from num. Right, let's copy paste this, I suppose. Now it works. What? What is different then? Is it the comma? Hey, seriously, the comma? It's the comma. Okay. Okay, so I guess it thinks that this entire thing is just the thing that we're looking for. So you have to add a comma after that. Alright. Well, okay. At least we figured that out. If you're stuck on a project and would like to see experienced developer work through the project, watch the project walkthrough video in the Get Unstuck section. No thank you. We're done. SQL queries don't just access raw data. They can also perform calculations on the raw data to answer specific data questions. Calculations performed on multiple rows of a table are called aggregates. Alright. In this lesson, we have given you a table named fake apps, which is made of fake mobile apps. Application data. Here's a quick preview of some important aggregates that we will cover in the next 5 exercises. Count, sum, max, min, average, round. Pretty standard stuff. Alright, so before we get started, take a look at the data in fake apps table. Alright, select all from fake apps. Okay, so we have on Zoom, we have base code, go where. So name, category, downloads, and price. Okay, what's next? Count. The fastest way to calculate how many rows are in a table is to use count function. Count is a function that takes the name of a column as an argument and counts the number of non-empty values in that column. Okay, so select count all from fake apps. 200. Alright. Add a where clause in the previous query to count how many free apps are in the table. And where price is 0. 73. So roughly 40%. SQL makes it easy to add all values in a particular column using sum. Sum is a function that takes the name of a column as an argument and returns the sum of all values in that column. What is the total number of downloads for all of the apps combined? Okay, so select sum of all apps from fake apps. Oh, downloads. And we get 3,322,760. It's pretty low. Max min returns the highest and lowest values in a column respectively. Okay. So what is the least number of times an app's been downloaded? Okay, so right. But we also could do like name, comma, min downloads, right? Yeah. Because just the download number doesn't really do us much good if we can't see everything. Can we do everything and then min downloads? Yeah, we can. Min downloads as download. Well, I guess as can we do it as blank? Yeah, we can. Okay, cool. Alright. Stop playing around. Delete the previous query. Done. Write a new query that returns the price of the most expensive app. So select max price from fake apps. $14.99. Damn, that's expensive. Which app is that? And Zoom. You gonna hack my ex-girlfriend? I'm gonna do once I learn how to. Hey, welcome to the chat hidden. How's it going? Just give me her, I don't know, number, I guess. now it sounds like I'm asking for ex-girlfriend's numbers. Okay, never mind. Ignore that. Ignore that. Abort. We need the average function to quickly calculate the average value of a particular column. Average downloads. Alright. So select average downloads from fake apps. 16k. 16.6. Write a new query that calculates the average price of all the apps. Average price. $2. Okay. Okay. Round. Alright, we can skip theory maybe. There's really nothing new here. Rounds the value in the column to 0 decimal places in the output. Okay. So return the name column and round the price column. Sure. Name, round, price. You can specify how to round from fake apps. I see. In the last exercise, we were able to get the average price of an app. Now let's edit this query so that it rounds the result to 2 decimal places. So we do select average price from fake apps and we do round. Right? Oh, 2 decimal places, round. Wait. Integer rounds the values in the column to the number of decimal places specified by the integer. Okay, so we need to do 2. There we go. Group by 1. Oftentimes, we want to calculate an aggregate for data with certain characteristics. For instance, we might want to know the mean IMDb ratings for all movies each year. We could calculate each number by a series of queries with different where statements, like so. Sure. Luckily, there's a better way. We can use group by to... I remember group by being sort of confusing when I was learning it the first time around. Because once you group something, it kind of messes with the data if it's not sort of the correct data, in a sense, that you're selecting. Group by is a clause in SQL that is used with aggregate functions. It is used in collaboration with the select statement to arrange identical data into groups. The group by statement comes after any where statement, but before order by or limit. Okay. In the code editor, type. Right, so we're selecting the price and we're counting everything from fake apps and regrouping by price. Select price, count all from fake apps, group by price. Grouped. Oh, no underscore, just a space. So what did it do? I guess it took the distinct price values, grouped the thing by them, and it counted all the things. Counted how many instances there are of that specific price. All right. Okay, so in the previous query, add a where clause to the count to count the total number of apps that have been downloaded more than 20,000 times at each price. So where downloads are greater than 20,000. Yeah. Remove the previous query. Sure. Write a new query that calculates the total number of downloads in each category. Total number of downloads in each category. All right, so let's, I usually like to start just like displaying everything. Makes it easier to see what you're working with. So we got this. Total number of downloads for each category. So we need category. And we need some downloads. Right? And then we group by downloads. No, we group by category. No, never mind. Category. Still no. Alright, let's see what this returns. Nothing. What? Select category and some downloads from fake app. Just download? Okay, I'm getting confused now. What? Fake app downloads. Okay, so category and the sum of downloads. Downloads, loads from fake app and group by category. Still no. What am I doing wrong here? From fake apps, group by category. Yeah. Select category and some downloads from fake apps. There we go. All right, that works. Minus the typos. Okay, group by 2. Sometimes we want to group by a calculation done on a column. For instance, we might want to know how many movies have IMDb ratings that round to 1, 2, 3, 4, 5. We could do this using the following syntax. Select round, IMDb rating. Okay, count the names from movies, group by round, and order by round. Okay. Or we could rename this column into something more simple, so we wouldn't have to type in the whole thing, round IMDb rating the entire time. However, this query may be time-consuming to write and more prone to errors. SQL lets us use column references in our group by that will make our lives easier. Oh, 1 is the first column selected, 2 is the second column selected, and 3 is the third column selected, and so on. Oh, the following query is equivalent to the one above, group by 1. Oh, okay. Alright, so suppose we have a select category. Category price and average downloads. From fake apps. And we group it by category and price. Write the exact query, but use column references, numbers instead of column names. Okay, so just 1 and 2. Except, does it have to be indented like so? Or was it the comma that it didn't like? I think it was the comma. Yep. Okay, so what did it do here? We're grouping by price and category. Oh, okay, so it just splits it like that. Okay. Having. In addition to being able to group data using group by, SQL also allows you to filter which groups to include and which to exclude. For instance, imagine we want to see how many movies of different genres were produced each year, but we only care about years and genres with at least 10 movies. We can't use where because we don't want to filter the rows. We want to filter groups. This is where having comes in. Having is very similar to where. In fact, all types of where clauses you learned about thus far can be used with having. Okay. So group by 1, 2, having count name more than 10. Alright, so suppose we have the query below, or we do select price, round, average, downloads, and count all from fake apps, and we group by price. It returns the average downloads rounded to the number of apps at each price point. Okay. However, certain price points don't have very many apps, so their average downloads are less meaningful. Okay, so we do having query price points that have more than 10 apps. What? Having more than 10 apps. Certain price points don't have very many apps. So having name less than more than 10? No. What if we include the name first? It's gonna be a nonsense probably, yeah. Oh, we have a count that we're counting everything. So, of course, having count greater than 10. Yeah. I completely somehow blocked the count out of my vision. Okay. So we learned count, sum, max, average, round, grouped by, and having. Now we have a quiz. Probably. Yep. How would you calculate the minimum number of stops from the train table? Minimum number of stops from the train table. So stop, min from train. Aggregate functions. Return, count the number of rows, compute a single result set from a set of values. Yeah. Which function takes a column and returns the total sum of the numeric values in that column? Takes a column and returns the total sum of numeric values. It's sum. What does the following query do? So we select the neighborhood and the average price from apartments and grouping it by neighborhood. So it calculates the average price of apartments in each neighborhood. Yep. The where clause filters rows, whereas having clause filters groups. I remember reading something remotely stating that having can be used with other things rather than just groups, but true? Yeah. The having clause was added in SQL because where could not be used with aggregate functions. Okay. What does the following query do? So we're selecting genre and we're selecting some, like, the total downloads from Kindle, and we're grouping by genre. So it returns the total amount of downloads for each genre. Yep. What does the following query do? We're selecting price. We're counting it from menu where orders are more than 50, and we're grouping it by price. So it calculates the total number of menu items that have been ordered more than 50 times for each price. Oh, I didn't turn on the door cam. There we go. Just gotta tweak the overlays a little bit. There we go. Find the error in this code. So having is used without group by. Or we could have where instead of having. What does the round function take as arguments? It takes a column name and the number of decimal places to round the values in the column to. What does the count function take as an argument? The name of the row. No, the name of the column or a star sign. Dunzo! Alright, we have, oh my god, we have another project. Sort of project, I guess. Yeah, these are gonna be coming quick. We have some off platform. Oh, we should be able to finish this today. We do have multiple tables. That's gonna probably be the hardest thing. But we should be finishing this today. Alright, let's take a break. It's time for one. 10 minutes as usual. No. Alright. We're back. Let's jump into it. Still have our dog cam on. Because God forbid we don't have it on. The extension warp will send us straight to hell. Alright. So we have a project. So we have startups table. Select all from startups. Oh my god, that's a big old table. Name, location, category, employees, raised, evaluation, founded, and stage. Alright. So, calculate the total number of companies in the table. So, select, count. Alright, I made my basic setup. Break time. Alright, have a good break. Check them. Count 70. Right? Yeah, we have 70 rows. Okay. This is typically you don't really have to count them. That if that's the information that you want to have, you can just do like select all. Scroll to the bottom and you have 70 rows. But okay, whatever. We want to know the total value of all companies in this table. Okay, so sum the total value, so valuation. Oh my god, that's million billion $974 billion. Whoa. All right. So what is the highest amount raised by a startup? Okay, max raised. That is $1.15 billion. What startup is that? Rebu. Okay. Edit the query so that it returns the maximum amount of money raised during seed stage. Alright. So max raised, where stage is seed. What? Is it where? Yeah. Oh, it's seed, capital S. No? No. Yes. Yes. Okay. All right. In what year was the oldest company on the list founded? So we could do multiple ways. We could do select all from startups where or we could do just show me all and show me max year. No, max founded. Min founded, actually. So it's Arendelle. In what year? 2009? Could that be the case? No. Alright, Min founded. 1994. There we go. It's much better. Why didn't it show me properly with the star sign? Do name. Rice Media, 1994. But if we do the star... Oh, now it works. Okay, that's odd. Return the average valuation. AVG valuation. Value. How do you spell valuation? Valuation. There we go. That's a lot of money. Return the average valuation in each category. So group by category. And let's do also the categories. Category, let's do descending. No, wait. Sort by. Or order by. Order by category. Descending. No, order by average valuation descending. Yeah, there we go. Can we also do average valuation as val avg, something like that, and then use the same keyword avg here? Yes, we can. All right, cool. And actually, let's wait. Is it round? Downed round to 0. Yeah, there we go. It's much better. Okay. Return the average valuation in each category. Kind of already did that. Round the average to do 2 decimal places, so 2. Okay. Return the average valuation in each category. Round the average to 2 decimal places. Lastly, order the list from highest averages to lowest. Already done that as well. What are the most competitive markets? First, return the name of each category with the total number of companies that belong to it. Alright, so we will do category with a total number of companies that belong to it. So count all. Well, actually, we can do just count all from startups. And then... Oh, no, we actually need the category. Because we will do grouping by category. Group by category. Right? Like so. And then filter the result to only include categories that have more than 3 companies in them. So having count greater than 3. Education, mobile, and social. Interesting. Let's see if there's a difference in startup sizes among different locations. What is the average size of a startup in each location? So we're doing average size of a startup. Is there a size in here? How do you measure the average size? By employees? I guess we could do employees. Employees. And we do average employees. What is the average size of a startup in each location? So I also need to do location. Well, we don't need the employees, I guess. All we really need is location and average employees. And then we group by location. So there we go. We can order by... let's do as average. Average, order by average, descending. And let's also have this as round to 2 decimal values. There we go. So San Francisco. Ooh, Silicon Valley comes second. Interesting. New York, Brooklyn, Fort Lauderdale, and Columbus in the last place. What is the average size of a startup in each location with average sizes above 500? So group by location having average above 500. Right? Yeah. Okay. We're done. Easy peasy. Another project. Oh, these are changing. Interesting. Analyze Hacker News trends. Codecademy launched Learn SQL from scratch. Communication. It's an engineering skill. Single origin app. Okay, Hacker News is a popular website run by Y Combinator. It is widely known by people in the tech industry as a community site for sharing news, showing off projects, asking questions, among other things. In this project, you will be working with a table named Hacker News that contains stories from Hacker News since its launch in 2007. It has the following columns: title, user score, timestamp, and URL. Alright, this data was kindly made publicly available under the MIT license. Alright. So start by getting a feel for the Hacker News table. Let's find the most popular Hacker News stories. Alright, so we select title and score. Not a score. Score from Hacker News. Ordered by score descending, limit to 5. So Penny Arcade, Surface Pro 3 update, hacking the status game, Postgres CLI with auto completion and syntax highlighting. Stephen Fry hits out an infantile culture of trigger words and save spaces. Reversal. Australian government picks ODF doc standard over Microsoft. Alright, so we have a score. Actually, I would like to see the entire table. Let's select everything from the table. Ooh, that's a big old table. A lot of these don't have titles. It's a big table. Holy crap. Okay. So, recent studies have found that online forums tend to be dominated by a small percentage of their users. 1990 rule. What is the 1990 rule? In internet culture, the 1% rule is a general rule of thumb pertaining to participation in an internet community, stating that only 1% of the users of a website actively create content, while the other 99% of the participants only lurk. Variants include 1990 rule, sometimes 99-1 principle, or the 89-10-1 ratio, which says that in a collaborative website such as Wiki, 90% of the participants of a community only consume content, 9% of the participants change or update content, and 1% of the participants add content. Alright. Similar rules are known in information science. For instance, the 80-20 rule, known as Pareto principle. Yeah, I'm familiar with Pareto principle. 20% group will produce 80% of the activity, regardless of how the activity is defined. Okay. So is this true of Hacker News? Is a small percentage of Hacker News submitters taking the majority of the points? First, find the total score of all stories. So, count score from Hacker News. 703. Could it be? Could it be? Oh yeah, probably. Like, these are pretty small digits. 131313, okay. So next, we need to pinpoint the users who have accumulated a lot of points across their stories. Find the individual users who have gotten a combined score of more than 200 and their combined scores. Alright, so we need user and we're counting the score. So we also have to group by user. Having more than 200, having a score or having count score greater than 200. Something went wrong. Alright, let's comment this out, see what cold tea. Okay, what if we group by user? Still getting one. Alright, what if we do user? Alright, we have a lot of users, so sum score, right? That way we see what each user has. And their combined scores. But we don't really... What if we don't group them? We're still getting pretty much the same thing. But I guess if we group them, we can then have having. So no one has more than 200. Unless I'm doing something wrong. Some score hacker group by user, having score. Oh, I'm still counting it. Sum. There we go. Alright, so then we want to add these users' scores together and divide by the total to get the percentage. Add their scores together divided by the total sum. What? Select 1, 2, 3. Divide by 6. Oh. Select 1, 2, 3. No, 1 plus 2. Do we need the decimal? Plus 2.0 plus 3.0. Divide by 6. I don't get it. Oh, we have to manually do that? Why 6? Because we only have 4. Doesn't make sense. So we could do do we really have to do it manually like that? Okay, well, sure. Let's do 517 plus 309 plus 304 plus 282. And I guess we divide by some score. Or no. Some sum of all the score. Yeah. Wait, no. 517 plus 309 plus 304 plus 282. 1412. Sure, let's do 1412. 1412. So it's getting 1. Doesn't make sense. Why 6,366? Is it oh, it's the total score. Yes? Huh? Why? You can sit. You can sit. Okay. So it's just the total score of all the 6366. What? Now we're getting zeros. Point zero. Oh, there we go. But we're getting the exact same number. I don't understand this. Hmm. Or do we have to just have an entirely separate thing? Like, just this, essentially? No, it's the same thing. I don't understand. The query should look like this. That is 22%. Okay, sure. Oh no. While we are looking at the power users, some users are rickrolling, tricking readers into clicking on a link to a funny video and claiming that it links to information about coding. How many times has each offending user posted this link? Okay, so we need a user. We also need URL. And we need a score. The sum of score, right? How many times has each offending user posted this link? So yeah, sum of score. And we are where URL equals we can do some regex. Can do anything beforehand, and then we do this. Right? Okay, so what will this give us? Nothing. Okay, select user where URL is this. Also nothing. Select everything where URL is this. Also nothing. What? Okay, let's just have a full URL like that. Alright, so we have that. So select user, select score, or the sum of score. And I think that's it. And we group by user, order by score descending. So Sony nom nom. Is that it? So select users, count all. From Hacker News, where URL. Ah, I didn't use like. That's why it didn't work. Group by user, order by score. Should have done some score. But it's the same thing. But what if we do count everything? Will it give me a different result, is the question. Oh, kinda. Okay. Interesting. Alright, which sites feed Hacker News? Hacker News stories are essentially links that take users to other websites. Which of these sites feed Hacker News the most? GitHub, Medium, or New York Times? First, we want to categorize each story based on their source. Alright, we can do this using case statements. Fill in the other when statements and the else statement. Sure. Select case when URL like. Oh, so we're categorizing by the URL. GitHub.com. Then GitHub. It would be actually helpful to see all of the available ones, but I guess we'll just give it a shot. So when URL like medium.com. then medium, when URL like NewYorkTimes.com, then New York Times. Else unknown, or just do other and as source from Hacker News. Okay, we have a bunch of others. We have only others. No, actually, no, we don't. We have Medium. Do we have New York Times is the question. I see GitHub as well. Can we group by case? No. Group by source? Yeah. And we have no New York Times. What if we do just times.com? There we go. We could even do select count all. Oh, no, we cannot. Oh, wait, no, yeah, we can. Count all. We just have to add a comma. Yeah. So, we have GitHub, Medium, and New York Times. Is that the case, though? Is that correct? Let's take a look. Else other NY Times. That didn't change the count here. Okay, that's pretty much identical to what I did. Next, build on the previous query. Add a column for the number of stories from each URL using count. Already did that. Also group by the case statement. Already done. Remember that you can refer to a column in group by using a number. Well, I just grouped it by source, so. Because we ended it as source. I guess if we didn't have a name, we could use the number, but we already did that. So what is the best time to post a story? Every submitter wants their story to get a high score so that the story makes it to the front page. But what is the best time of the day to post a story on Hacker News? Before we get started, let's run this query and take a look at the timestamp column. Sure. Actually, before we do that, it's lunchtime. So we'll finish this up after lunch. In the meantime, I do wish you guys have a good lunch. Also, if you're not having lunch, you can take a look at Thor as he's laying here peacefully, staring at himself in the mirror like the diva that he is. Other than that, have a good lunch, and I'll see you guys in 30 minutes. In our usually scheduled programming. I think that's the way they say it. Maybe? I don't know. Thor came back from outside, chewing on his tasty bone now. And we can jump back into SQL. Okay, so where did we left off? We were trying to get... we were trying to get the sources, right? Yeah. Or how many sources per article, or rather okay, how many sources? No. Okay, I'm confused. Where was the which of these sites feed Hacker News the most? That's what we were trying to get. Alright, every submitter wants their story to get a high score, so that story makes it to the front page. But what is the best time of day to post a story on Hacker News? Before we get started, let's run this query and take a look at the timestamp column. Sure thing. So we're selecting timestamp from Hacker News and limit to 10. Alright, so it's year, month, day, and then the hours. What is T? Z. Interesting. Notice that the values are formatted like so. If you ignore the T and Z, the format is sure. SQLite comes with strf time function, a very powerful function that allows you to return a formatted date. It takes two arguments, takes the format and the column. Okay, I'm a little bit familiar with the strf time. strf time. So we want to do just the hours. I'm stamp. Okay. From Hacker News group by timestamp and limit to 20. So 5, 8. Okay. What do you think this does? Well, like I said, it returns us the time, but why group it by the timestamp? Should probably group this by this. I guess it doesn't matter. It's the same thing. So, essentially, well, some of the groups are repeating. Okay, what do they say? It does. Well, yeah, okay. Okay, now we understand how string format time works. Let's write a query that returns 3 columns. So we need the hours and timestamp, the average score for each hour. So AVG score. So we can actually remove this and do this as hours, we can get the average score and we get the count of stories. So we group by count. Makes the most sense, probably. Or now we can actually group by hours. That would make more sense. Well, let's remove the limit. There we go. So average score. Let's round it out to 2 decimal points to make it a bit more readable. And we could also group or order by count, descending. There we go. So, the best hour to post is... Well, currently the most posted hour is 3 o'clock. The best for the score would be probably 6, because it has the best average score. Right? Let's edit a few things in the previous query. Round the average scores. Already did that. Rename the columns to make it more readable. Already did that. Add a where clause to filter out the null values in timestamp. Where? Oh, where? Timestamp is not null. Alright, it's pretty much the same thing. The best time is 6 o'clock. The second best time is probably 7 in the morning. The worst time is 10 o'clock. No, actually, it's 3:08, so 10 o'clock. 10 a.m. No, actually 8 in the morning. Okay. Well, we're done with this. Okay, so multiple tables. This will be interesting. Okay, so in order to efficiently store data, we often spread related information across multiple tables. For instance, imagine that we're running a magazine company where users can have different types of subscriptions to different products. Different subscriptions might have many different properties. Each customer will also have lots of associated information. We could have one table with all of the following information, such as order ID, customer name, customer address, subscription ID, subscription description, monthly price, length, and purchase date. However, a lot of this information would be repeated. If the same customer has multiple subscriptions, that customer's name and address will be reported multiple times. If the same subscription type is ordered by multiple customers, then the subscription price and subscription description will be repeated. This will make our table big and unmanageable. So instead, we can split our data into 3 tables: orders, subscriptions, and customers. Okay, so in this lesson, we'll learn the SQL commands that will help us work with data that is stored in multiple tables. Alright. So examine these tables by pasting the following code into the editor. At the same time? Probably not, right? Oh, we can do it at the same time. So the question is, how does it order, customer ID, subscription, purchase date, subscription ID, description, price per month? Okay, it's not very clear which... oh, well, I guess we can use this to orient ourselves a little better. Customer ID has 2 customer IDs. Customer ID, customer name, address. Oh, they link with foreign keys. Okay. Alright. Let's take a look at them one at a time. So we have order ID, customer ID. This is orders. So... wait, it's still returning everything. Oh. Okay, so orders has order ID, customer ID, subscription ID, and purchase. Okay. Then we have subscriptions, which has subscription ID, description, price per month, and subscription length. And finally, we have customers with customer information, such as name and address. Okay. Pretty straightforward. Combining tables manually. Let's return to our magazine company. Suppose we have 3 tables described in the previous exercise shown in the browser on the right. We're gonna try something new. Ooh, new. We just look at the orders table. We can't really tell what's happening in each order. Can we? Oh, not. We have some information. We know that the customer number 2 has 2 different subscriptions that he purchased on the same day. We know at least that much. Let's examine our order with order ID of 2. Was purchased by the customer with a customer ID of 2. Yes. To find out customer's name, we'll look at the customers table and look at the item. Look for the item with a customer ID value of 2. Jane Doe. She lives at 456 Park Avenue. Doing this kind of matching is called joining 2 tables. Using the tables displayed, what is the description of the magazine? Okay, using the tables displayed, what is the description of the magazine ordered in order ID 1? So we have subscription ID 3. We go to subscriptions, sports magazine. Yeah. Using the display tables, what is the customer name of the customer or in order ID 3? Order ID 3, customer 3. So we go to customers 3 and get Joe Schmo. Yep. Combining tables manually is time consuming. Luckily, SQL gives us an easy sequence for this. It's called a join. If we want to combine orders and customers, we would type select all from orders, join customers on customer, on orders customer ID equals customer.customer ID. Let's break this down. So the first line selects all columns from our combined table. If we only want to select certain columns, we can specify which ones we want. That's pretty standard. The second line specifies the first table that we want to look in, which is orders. Okay. The third line uses join to say that we want to combine information from orders with customers. Okay, and the fourth line tells us how to combine these 2 tables. We want to match orders tables customer ID column with customer tables customer ID column. Because column names are often repeated across multiple tables, we use the syntax tablename.columnname. Okay, to be sure that our requests for columns are unambiguous. In our example, we use the syntax in the on statement but we will also use it in the select or any other kind statement where we refer to column names. Okay. For example, instead of selecting all the columns using the star, we only, if we only wanted to select orders tables, order ID column, and the customer tables, customer name column, we could use the following query. Yeah, makes sense. All right, so we need to join the orders table and the subscriptions table and select all the columns. Make sure to join the subscription ID column. So select all from orders, join subscriptions on orders dot subscription ID equals customer dot customer ID. Nope, not the dot. It's the underscore. Nope, probably misspelled something. Oh, subscription ID. Never mind. Now it should... Wait, what? Join customers. Join subscriptions. Or we could do... Oh no, it doesn't make sense. Or does the way that we join, like the order, matter? Subscription ID, customer, orders. I mean, it should work. Do we need the comma here? No. Orders table, select all columns. Make sure to join the subscription ID column. What is different? Select all from orders, join subscriptions on orders.subscription ID equals subscriptions. Oh, what am I doing? Customers. Jesus. Subscriptions. Subscription. Subscriptions. No? What? Subscription ID. Orders. Subscription ID equals subscriptions. Subscription ID. Yeah, it's the same thing. Is it the comma now? Yeah, it was the comma. Okay. So we have subscription ID here and subscription ID here. Okay, and that's how it matches them. Okay. So then don't remove the previous query. Add a second query after the first one that only selects rows from the join where description is equal to fashion magazine. So select. Select all from. How do we still refer to orders? Yeah, oh, we just, okay, never mind. It's just the same table. I thought we were supposed to like somehow refer to the first query on where description is fashion magazine or equals. Ah. No. Subscriptions, I have to specify which table I'm referring to. So subscriptions dot description equals fashion magazine. Still no? From orders. Join subscriptions. Orders, subscription ID, subscription ID. Where subscriptions dot description equals fashion magazine. I mean, it should be fine. Or are we supposed to comment that out? Or do we just add this here? No. Wait, what? Why did it? I'm confused now. Join subscription on orders. Okay, so this is odd. Commenting it out returns something, but deleting this. Oh, now it returns something, but that's not the way they wanted us to do it. From wait, short key for capitalizing. Shift F3. Does that work? No. Just it's multiple selection. It's a search even. Not really multiple selection. Okay, whatever. Let's just do it the way they want it. It's a bit dumb, but they still don't accept it. What? Is it because of the semicolon? Yes, it is. Okay, so semicolons matter. Commas also matter, apparently. But now we have a mess. Okay, well. Inner joins. This is the confusing part. Let's revisit how we joined orders and customers. For every possible value of customer ID in orders, there was a corresponding row of customers with the same customer ID. What if that wasn't true? For instance, imagine that our customer table was out of date and was missing any information on customer 11. If that customer had an order in orders, what would happen when we join the tables? Well, we'd get a null value, probably. When we perform a simple join, often called an inner join, our results only include rows that match our on condition. Okay, consider the following animation, which illustrates an inner join on two tables, table 1c2 and table 2c2. Okay, so these don't match, so it just removes them. The first and last row have matching values of C2. The middle rows do not match. The final result has all values from the first and last rows, but does not include the non-matching middle row. Alright. Suppose we are working for... here come the yawns. Suppose we are working for the Codecademy Times, a newspaper with two types of subscriptions, print newspaper and online articles. Some users subscribe to just the newspaper, some subscribe to just the online edition, and some subscribe to both. There's a newspaper table that contains information about the newspaper subscribers. Count the number of subscribers who get a print newspaper using count. Okay, so select count all from newspaper 60. Okay, don't remove your previous query. There's also online table that contains information about the online subscribers, so we do the same, I assume. From online 65. Join newspaper and newspaper table and online table on their ID columns. The unique ID of the subscriber. Okay. We have to kind of specify now. Newspaper has ID and online has ID. Oh, they store it. Oh, okay. Store it like that. Okay, well then, select all from paper, join online on newspaper dot ID equals online dot ID. No. Is it still like angry that I'm not using capital letters? Maybe. Or not adding semicolons or something. I mean, it should work. Okay, what if we do count all? We get 50. That makes no sense. Oh, it wanted us to count it. Okay, count 50. So the default join is the inner join, but it makes no sense. At the very... Huh. Oh, it makes perfect sense because this returns all of the users who have both the online and newspaper. Right? I think so. Thank you. I got more water. Be jelly. um... Okay, yeah, that makes sense. Alright, let's move on. Left joins. So, what if we want to combine two tables and keep some of the unmatched rows? SQL let us do this through a command called left join, and left join will keep all rows from the first table, regardless of whether there's a matching row in the second table. Okay. The first and last rows have matching values of C2. The middle rows don't match. The final result will keep all rows of the first table, but will omit the unmatched row from the second table. Okay, the question is how do we know which one's the left one? The animation represents table operation produced by the following command. So, okay. First line selects all columns from both tables. The second line selects table 1. The left table? Oh, yeah, okay. Which is the left table. And we left join table 2. So we will be using information from table 1 and omitting, missing information. But if left join has gaps, then those gaps will be transferred to the final table. I think. The for line tells SQL how to perform the join by looking for matching values in column C2. Okay. So let's return to our newspaper and online subscribers. Suppose we want to know how many users subscribe to the print newspaper but not to the online one. Start by performing a left join of newspaper table and online table in their ID columns and selecting all the columns. Sure. All from newspaper. Left join online on newspaper.id equals online.id. Yeah. Don't remove the previous query. In order to find which users do not subscribe to the online edition, we need to add a where clause. Add a second query after your first one that adds the following where clause to clause and condition. Okay. Where online ID is null. Did you add a second query that has a left join and a where clause? Yes, I did. Semicolon again? No. Select. What? Why are there two semicolons? Left join online. Newspaper ID, online ID. Select all newspaper, left join, online, on newspaper ID, online ID. So we need two semicolons here? No, we actually, that was the problem. We don't need two semicolons. Okay, so Wida Ardini, right? She has an ID of 71788. 71778. Okay, so it makes sense that she appears in this table because we did a left join. And her null value became the value of the newspaper. Yeah. Same with Esteban Pittner. And same with all these folks. Okay. Let's return to our example of the magazine subscriptions. Recall that we had three tables: orders, subscriptions, and customers. Each of these tables has a column that uniquely identifies each row of that table. Customer, subscription ID, customer ID. Roger. These special columns are primary keys. Primary keys have a few requirements. None of the values can be null. Each value must be unique. You can't have two customers with the same customer ID in the customers table. And a table cannot have more than one primary key column. Yeah, makes sense. Note that the customer ID, primary key for customers, and subscription ID, the primary key for subscriptions, both appear in this. When the primary key for one table appears in a different table, it's called a foreign key. Okay. So customer ID is primary key when it appears in customers, but a foreign key when it appears in orders. In this example, our primary keys all had somewhat descriptive names. Generally, the primary key will just be called ID. Foreign keys will have more descriptive names. Will they? I mean, foreign key columns, maybe. The foreign keys themselves will still be like 1, 2, 3, and so on. So why is this important? The most common type of joins will be joining a foreign key from one table with a primary key from another table. For instance, when we join orders and customers, we join on customer ID, which is a foreign key in orders and the primary key in customers. Does it matter, like, which can we join a primary key on a foreign key? I don't think it matters. Okay, so suppose Columbia University has two tables in their database. The classes table contains information on the classes that the school offers. Its primary key is ID. The students table contains information on all students in the school. Its primary key is ID. It contains the foreign key, class ID, which corresponds to the primary key of classes. Okay, so perform an inner join of classes and students using the primary key and the foreign keys described above, and select all columns. Alright, so select everything from classes inner. Oh. It wants us to do an inner join. We don't have to specify inner join. We can just do join. Join students. Students on. So we do classes dot class ID equals students dot actually classes ID on students class ID. That should be it, yeah. Okay. Cross join. So far we focused on matching rows that have some information in common. Sometimes we just want to combine all rows of one table with all the rows of another table. For instance, if we had a table of shirts and a table of pants, we might want to know all the possible combinations to create different outfits. Okay, so select shirts, shirt color, pants, pant color from shirts, cross join pants. The first two lines selects the columns. The third line pulls the data from the table of shirts. The fourth line performs a cross join on pants. Allows for return of results from more than one table by joining them together with other results based on common column values. Oh, but cross joins don't require an on statement because we're not really joining on any column. We have three different shirts, white, gray, olive, and two different pants. Results might look like this. Okay. When we need to compare each row of a table to a list of values, let's return to our newspaper subscriptions. This table contains two columns that we haven't discussed yet. Start month, first month where the customer subscribed to the print newspaper. 2 for February, okay. And end month, the final month where the customer subscribed to the print newspaper. Suppose we wanted to know how many users were subscribed during each month of the year. We would need to know if a user was subscribed. Okay. My brain is slowly shutting down for some reason. Eventually we'll use cross join to help us, but first let's try a simpler problem. Let's start by counting the number of customers who were subscribed to the newspaper during March. Okay, so select count all from newspaper where start month is less or equal to 3 and start month is greater or equal to 3. So you got 4. But the Academy's not happy. Why? Oh, I did 2 start months. 13. That makes more sense. Okay, don't remove the previous query. Let's just investigate 1 month at a time. In order to check across all months, we're going to use a cross join. Our database contains another table called months, which contains the numbers between 1 and 12. Select all columns from the cross join. Our newspaper and months. Select all from newspaper cross join months. I should just probably permanently use caps lock at this point. So that's it. Okay. It's giving us a lot. Oh, it's wait, what? Okay. Create a third query where you add a where statement to your cross join to restrict the 2 conditions. Your nope. Oh, month. Month. Wait, what? Month? Condition start month is less than month, and month is less than month. We'll select all months where user is a subscriber. Okay, so we're getting... I don't know what we're getting. Create a final query where you aggregate over each month to count the number of subscribers. Count everything. Everything I said. From Probably newspaper. Okay, so we're just doing the same thing combined now, I guess. Cross join months, right? Where and copy this and group by month. Okay, what did we get? We got this. Holy crap, this is ugh. This is just ugh. Month count. Cross join months. And we're grouping by month. I mean, I largely understand it, but the question is, where did this month keyword come from? Explain. The selected code is performing a query on a database table called newspaper. It's selecting the month column. Oh, right, we're selecting the month column. So, where start of the month is less than month. Now, this doesn't make sense. The range is determined by the start month and end month columns of the newspaper table. The result is grouped by month, providing a count for each month in the range. Okay, let's say I get it, maybe. Sometimes we want to stack one dataset on top of another. Well, the union operator allows us to do that. Suppose we have two tables and they have the same columns. Sure. We combine these two with union. Okay. So SQL has strict rules for appending data. Tables must have the same number of columns, and the columns must have the same data types in the same order as the first table. Alright, let's return our newspaper and online subscriptions. We'd like to create one big table with both sets of data. Use union to stack newspaper table on top of the online table. Okay, so select all from newspaper, and we do union, and we select all from online. Is that the case? Seems like it. Okay. With. Oftentimes we want to combine two tables, but one of the tables is the result of another calculation. Let's return to our magazine order example. Our marketing department might want to know a bit more about the customers. For instance, they might want to know how many magazines each customer subscribes to. We can easily calculate this using our orders table. The query is good, but customer ID isn't terribly useful for a marketing department. They probably want to know more about... They want to know the customer's name. we want to be able to join the results of this query with our customer table, which will tell us the name of each customer. We can do this by using a with clause. With previous results as. So we can format it in parentheses and then have another select statement doing whatever we need to do on that one. So the with statement allows us to perform a separate query, such as aggregating customer subscriptions. Previous results is the alias that we'll use to reference any columns from the query inside of the with clause. We can then go on to do whatever we want with this temporary table, such as join the temporary table with another table. Okay. So place the whole query below into a with statement inside parentheses and give it name previous query. So with previous query as, right? Yeah, as. And then we do select customer ID, count, subscription ID as subscriptions. It's probably not going to be happy about the capitalized S. Subscriptions from orders group by customer ID. All right, so that goes here, and then we have a separate select. Select the following columns. So select customers.customer name and previous query dot subscriptions from orders. Oh, we have to join them afterwards. So previous query we then join the orders on so we will do previous query dot customer ID equals orders dot customer ID. I think. No, please. It deleted everything. God damn it. Did it? No, thank God. Right, so running this. No. from previous and join on customers. We're doing orders. The previous query. Oh, we were doing customers here. Previous query. Okay. Customers. So we will do customers. New. On previous query. Dot customer ID. Customers. Customer ID. Join customers. Previous query. Customers.customer name. Previous query. Dot subscriptions. Group by customer ID. Orders. Usutomer. Subscripted. I cannot spell today. Okay. That works. My God. Okay. We're done. Let's take a break. My brain is exploding. Yeah, see you. And we're back. Take a sip of water. A little bit refreshed. At least for the next hour. Guess we can jump back in. Alright, so we have a quiz. So, why a cross join is not so useful? It combines all foreign keys into one table called foreign keys. It combines every row in one table with every row in another table. It nullifies all primary keys. Does it nullify all primary keys? No, it doesn't. It just combines every row in one table with every row in another table, which is not entirely useful in general. So we have two tables, teacher and student. Each student belongs to a teacher. Complete the query to join the tables on the teacher ID. So we're joining students on teachers, and we do each student belongs to a teacher. So we're doing students.teacherID equals teacher ID. I mean, it's the only one that makes sense because it has like proper syntax for it. But yeah, okay, never mind. In a left join, if a join condition is not met, what will it use to fill columns on the right side? Column name.id. Good question. So if a join condition is not met, what is a join condition? Join condition, join condition, join condition. So a join condition, I assume, would be that the values in a column on both tables match. So if they don't match, then we take the values from the left table to fill the right table. So primary key, ID, or null values. Primary keys? Column name dot ID. Null values was the correct answer. All right. Union allows us to stack one data set on top of another. Well, that's true. You have two tables, authors and books. Each book belongs to an author and references that author through a foreign key. Okay. If the primary key of the author table is ID, what would be the most sensical name for a foreign key in the book table that references the ID column? Oh my god, such a brain. Alright, let's, you know what, let's visualize it. Let's visualize it. Alright, so we have two tables. We have table authors, and we have a table books. Each book belongs to an author and references that author through a foreign key. So it will have author ID, right? If the primary key of the author's table is ID, so ID, right? What would be the most sensical name for a foreign key in the books table that references the ID column? So auth ID, author ID, yes, okay. Just sometimes these questions, or my brain, probably the case of my brain being slow today. What is the best definition of a primary key? A unique identifier for each row or record in a given table. Sure. A foreign key with distinct attributes. No. A null value. No. A primary record in a database that serves as a template for all other records. No. This one. What is the best definition of a foreign key? A column that contains the primary key of another table in the dataset. Yeah, that's the one. Why is cross join not so useful? Combines every row in one table with every row in another table. Alright, which keyword would you use to alias recipe name and chef's name in the following query? As, obviously. What kind of join is in the animation below? It's the inner join. Yep. So we have two tables. So it's student.teacherID and teacher.id. What is the difference between inner join and left join? Left join combines rows from two or more table, but unlike inner join, it does not require the join conditions to be met. Left join is an obsolete form of inner join. Inner join joins rows with a table. A left join joins rows between tables. So that's the correct one. And if a left join, in a left join, If a join condition is not met, what will it use to fill columns on the right table? It will use null values, as we just figured out. Okay, so we have a project. And then we'll go off platform a little bit. But we're approaching the end of this nightmare of a day. Let's practice what we learned about joins by combining rows from two different tables. Suppose you're a data analyst at Lyft, a ride-sharing platform. For a project, you were given 3 tables: trips, riders, and cars. Autonomous cars. Have fun. What? Okay. So, let's write the following queries. Oh my god. Let me select them, please. Let's take a look. So we have trips, ID, date, pickup, drop off, rider ID, car ID, type, and cost. Then we have riders. I'm seeing 4 tables. Trips, riders, cars. Why? What? Why does riders have 2 tables? What if we remove this and take a look at just the riders? Okay. So just 4 riders? Okay, what about riders 2? That's 3 riders. Sure. Alright, what is the primary key of trips? ID. Primary key of riders is ID. And primary key of cars is also ID. Try out a simple cross join between riders and cars. Okay, so select all from riders, cross join cars on so we would do riders. Oh, we don't need to specify the on for cross join. Okay, so we got a bunch of gibberish. Yeah, basically. So, is the result useful? No, it's not useful, Uncle Codecademy. Suppose we want to create a trip log with the trips and its users. Find the columns to join between trips and riders and combine the 2 tables using a left join. Thank you. Let trips be the left table. Okay, so select all from trips or left join riders on trips dot. Wait, so we have trips and riders. Trips has rider ID, so we can do rider ID and riders just have ID. So riders dot ID. Right? What is this though? So we got different times. We have the cars that they were using. Have the costs. And we joined. So this is rider ID. We joined rider ID with the rider ID here. Right, since it didn't have any results on the rider ID here, it just filled it with nulls. Okay, makes sense. Suppose we want to create a link between trips and the cars used during those trips. So, find the columns to join on and combine the trips and cars table using an inner join. All right, so from select from trips inner join cars on. So we have trips, which has car ID. So trips.car ID. And we do with cars, which has just ID. So cars.id. Alright, so this is our car ID. And this is the car ID used for the trip. Okay. So that makes sense. The new riders data are in. There are 3 new users this month. Stack the riders table on top of the new table called new table riders 2. Alright, so select all from riders. And we do a union with select all from riders 2. Okay. And we can actually, when, I think, what is the keyword? Let's duplicate this and go back a few lessons. Back. Here? Or is this the test? No, with. Yeah. Where was it? Yeah, there. So we can do with, right? With all writers as, and we do the parentheses. So now we have all the writers in one table called all writers, right? So we can reference it later. And now we can write our new select statement on top of that. So what is the average cost for a trip? So we can do select total trips. Our writers stuff doesn't have referred. What is referred? Writers referred. Oh, I guess it's just which writer referred them. Okay. Well, let's comment this out. Leave it for a bit later. So what is the average cost for a trip? So we just do select blam, no, ABG cost, because we have trips and cost. Yeah. From trips the average cost is $31.95, $9.15, or 31.90. Lyft is looking to do an email campaign for all the regular users. Find all the riders who have used Lyft irregular users. Find all the riders who have used Lyft less than 500 times. Okay, so we can go back to our all riders table. Stop. And we can do select. We can do select all from all writers where total trips is less than 500. There we go, and we get the same thing that we wanted to get. Okay, so calculate the number of cars that are active. Okay, so cars has active column. So select everything from cars where the number of cars that are active, so count everything from cars where status is active. 3. Could it be? Let's comment this out. Let's select all from cars. Oh, we only have 4 cars. Okay. Lyft is very startup-y at the moment. Okay, yeah, it works. And it's safety recall time for cars that have been on the road for a while. Write a query that finds the 2 cars that have the highest trips completed. Okay, so I guess we just do the same thing. Actually, we can reuse this. Select count, trips, and we do order by count trips descending, and we limit to 2. Wait. Oh, is it total trips? Wait. It's trips completed. Oh. Okay. Trips completed. Let's do as TC. Sure. From cars and group. No, not group. Order by TC, and let's limit to 2. We can also do like model. Wait, something's off. Trips completed. Oh. Wait, what? Oh, it's 2 different cars. Okay, so actually we're supposed to do... let's do all. From cars, and we will just order by trips completed, descending, and also limit to 2. There we go. So these should be the 2 topmost, right? What? Oh, there we go. Okay. Yes. Ugh. My brain. My poor little brain. PostgreSQL, setting it up locally. Oh my god. I probably do not have the brain power for it today. What else have we got? Base basketball data. Setting up PostgreSQL locally. Have we done that? No, we haven't. Where was it? We have mixed messages, basics of backend development. Where did they go through PostgreSQL setup? Build a backend with Express.js. No. It's definitely not. Oh, I skipped that thing. I skipped database basics, just jumped working to databases. Oh my god. Okay, let's go next. And we have a bunch of articles. Pronouncing SQL or SQL. What? Why does it matter? I know, tomato, tomato, but I have people tell me I say it wrong when I say each way, which has left me rather confused. So I decided to do some research and figure out how SQL is actually pronounced. SQL is language used for querying and managing data in a relational database system. Some people say SQL and some people say SQL. This difference in pronunciation also affects the writing of documentation. The indefinite article that is used before the term a or an is based on how it's pronounced. Try saying ASQL and an SQL. No one wants to sound ignorant, so which way is correct? Turns out they're both correct and acceptable. Of course they are. But that the SQL way of saying is more official. SQL was initially developed by IBM. At IBM by Donald Chamberlain and Raymond Boyce. It was initially called Structured English Query Language and pronounced SQL. though it later had to have its name shortened to structured query language due to trademark issues. It was created to supplant the then popular Quell database language, and the name SQL was meant as a pun. It was the sequel to Quell. However, this leads to the big question: was language still called SQL after the name change? If you look at Oracle's official documentation in SQL, it says still pronounced SQL. However, if you look at MySQL's official documentation, it says MySQL is officially pronounced MySQL, not MySQL. And Wikipedia says SQL is officially pronounced SQL, and references to O'Reilly's book on the subject. So this is no help. The major sources aren't agreeing on the way it's officially pronounced. Then a thought occurred to me. SQL was created in the 70s. The creators are probably techies. I can probably just email them and ask them how it's pronounced. Ray Boyce had passed away at a young age, but Don Chamberlain was alive and now teaching at a university. I felt a little silly, but I decided to fire off a short email to him. Hello Dom, I'm sorry to waste your time with such a silly question, but I've often heard SQL pronounced SQL or as SQL. I've also seen the official pronunciation listed both ways. According to Wikipedia, you and Raymond Boyce created a language, and it was shortened to SQL after some legal dispute. So my question is there an official pronunciation to SQL? Thank you for your time. And he replied, hi Pat. Since the language was originally named SQL, many people continue to pronounce the name that way after it was shortened to SQL. Both pronunciations are widely used and recognized. As to which is more official, I guess the authority would be the ISO standard, which is spelled and presumably pronounced SQL. Okay. I felt a little dumb wasting his time with such a goofy question, but I was thrilled he replied back. Later I found out that he himself pronounced it as SQL. So it's interesting he would be so unbiased. Though I suppose his pronunciation is consistent with him noting that the original guys kept calling it SQL. With this, I felt I had found my answer. Both were acceptable, though the standard indicated SQL was probably more official. Okay. Alright, what else we got? Article, Understanding SQL and NoSQL databases and different database models. Sure, let's take a look at this one. Honestly, at this point, I can only read articles because my brain is just spaghetti. Understanding SQL. Holy crap, this is a huge article. Well, let's give it a shot. Actually, this article is depreciated and no longer maintained. Reason, we have rewritten our introductory database content. See instead. Okay. Let's do a focused reading, an ASMR reading. Let's get the mic up close. Yeah, there we go. All right. When most people think of a database, they often envision the traditional relational database model that involves tables made up of rows and columns. While relational database management systems still handle the lion's share of data on the internet, alternative data models have become more common in recent years as developers have sought workarounds to relational models' limitations. These non-relational database models, each with their own advantages, disadvantages, and use cases, have come to be categorized as NoSQL databases. This article will introduce you to a few of the more commonly used NoSQL database models. It will weigh some of their strengths and disadvantages, as well as provide a few examples of database management systems and potential use cases for each. Hey, Vinci G! Welcome to the stream. Or should I say, welcome back to the stream. How's it going, man? How's your Monday? How's your weekend been? What have you been up to? We are learning SQL. Or at least trying to, because my brain is mush today after the weekend, and it's Monday, so it's my brain's still on vacation. Nonetheless, we did get through a unit of SQL, so we're just kicking it easy for the last couple of hours. All good, been learning Docker and Kubernetes. How's that going? Where are you learning that though, as well? Like some course or? I hope the music's not too loud. Probably not the best time to ask, like towards the end of the stream, but well, the end. We still have 2 hours. Bum 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 bum. Databases are logically modeled clusters of information, or data. No crap. It's data. A database management system, DBMS, meanwhile, is a computer program that interacts with the database. DBMS allows you to control access to a database, write data, run queries, and perform any other tasks related to database management. Although database management systems are often referred to as databases, the two terms are not exactly interchangeable. A database can be any collection of data, not just one stored on a computer, while a DBMS is the specific software that allows you to interact with a database. Okay. All database management systems have an underlying model that structures how data is stored and accessed. A relational database management system, an RDBMS, is a DBMS that employs the relational data model. Okay. In this model, data is organized into tables, which in the context of RDBMSs are more formally referred to as relations. Okay, so primary foreign keys. I'm assuming that's what they're talking about. Relational database management systems typically employ structured query language for managing and accessing data held within the database. Historically, the relational model has been the most widely used approach for managing data, and to this day, many of the most popular database management systems implement the relational model. Alright. However, the relational model presents several limitations that can be problematic in certain use cases. Alright, for instance, it can be difficult to scale a relational database horizontally, so adding new columns. Or, wait, what is horizontal scaling in a database? It's like adding more tables that connect to other tables. What? All right, let's take a look. Horizontal database scaling. Horizontal scaling, also known as scale-out, refers to bringing on additional nodes to share the load. Tells me nothing. What is this? Vertical scaling. Horizontal scaling. Okay, so when you need to add more resources to a server rack to meet the expected needs, then it's vertical scaling. When you need to add more servers in the system to meet the expected needs. Then it's horizontal scaling. But that's, is it in databases? I guess it's using database as like a general term here, but not as in like database. Or maybe I just don't understand databases. What does database scaling mean? The term database scaling refers to the process of chaining database system capacity depending upon the amount of data or user activity occurring at any given time. There are two approaches to database scaling, horizontal and vertical scaling. Okay, the vertical scaling approach. The vertical scaling approach, sometimes referred to as scaling up, focuses on adding more resources and more processing power to a single machine. Okay, so these additions may include CPU, RAM, upgrades, which will increase the processing speed of a single server, or increase the storage capacity of a single machine to address increasing data requirements. Okay, so hardware. Upgrading hardware. One of the advantages of scaling vertically is that it's easier than alternative horizontal scaling approach, specifically since hardware resources and or computing resources are only being added to one machine. There's less complexity involved. This extends to the initial vertical scaling of the existing machine or existing server, as well as less complicated maintenance going forward. Further, since only one machine is being upgraded, vertical scaling is often a more economical choice in the short term than the horizontal scaling approach. With that said, there are some disadvantages to the vertical scaling approach as well. With one machine, there's a limit to the amount of upgrades or expansions that can occur, of course. This means that an organization's scalability needs may not be met if their single machine doesn't have the necessary expansion capability. Okay, so MongoDB Atlas makes it simple to vertically scale up or down as needed. You can even enable auto scaling so your available resources always meet your needs. So I don't understand the need to separate these distinctions so much, because eventually you will probably need to scale both ways. Like, unless, okay, sure, if your company is using one computer, like, probably if you max upgrade the hardware, you probably will last a while. But if your company grows and grows and grows, you will have to scale both vertically and horizontally eventually. Okay, so the main benefit of vertical scaling is that nothing changes about your database infrastructure other than the hardware specifications of the machine running the database. As such, it's transparent to the application. The only difference is that you have more CPUs, memory, and/or storage space. Vertical scaling is a good option to try first if massive storage and processing are not required. Yeah. The downside of scaling up is that servers with more storage and processing power can be a lot more expensive. Yeah. There's also a physical limit on the amount of CPUs, memory, network interfaces, and hard drives that can be used on a single machine. For those scaling up, using a cloud platform provider, you will eventually reach the highest tier of machine available. Okay, that makes sense too. The available configuration options from cloud providers may be limited, meaning that you may need only 10% more resources, but the next available tier has 50% more resources for 50% more cost. Also makes sense. If scaling vertically requires a migration between hardwares, it could result in downtime or service disruption. Yeah, makes sense. Okay, so horizontal scaling approach sometimes referred to as scaling out, entails adding more machines to further distribute the load of the database and increase overall storage and or processing power. There are two common ways to perform horizontal scaling. They include sharding, which increases the overall capacity of the machine, and replication, which increases the availability and reliability of the system. Okay, so horizontal scaling is infinitely scalable, as you can always add another machine while you may not be able to buy a larger machine if you are already using the largest machine available. Okay. There is more predictable increase in pricing. Adding additional machines is a predictable cost when upgrading to larger machines. While upgrading to larger machines may have increasing costs for smaller gains in performance. Horizontal scaling can also deliver better performance and customer experience. An example of this is distributing with global clusters to deliver better performance in each region. Okay, so horizontal scaling may require application architecture and code changes due to the distributed nature of the data. How you store and query the data can significantly affect your application performance. Database systems that are scaled horizontally can be more complicated to manage and maintain, leading to more work for you and your team. Okay, so we have sharding. Okay, so it just splits the data between the machines. The sharding method of horizontal scaling involves dividing a large database into smaller, more manageable pieces, called shards, and then distributing the shards across multiple machines. Each shard contains a subset of data, and each machine is responsible for storing and performing requests for a specific set of shards. This approach to horizontal scaling improves the system's fault tolerance and availability, as a single point of failure in one machine does not affect the remaining machines. However, this approach also adds additional complexity as it's important to make sure data is evenly distributed across the shards and there's no duplicated or lost data. Okay. Okay, why is it important that it's evenly distributed, though? Like, if you have 3 machines, right, and you had, or if you have one machine that's at 100% capacity, then you buy 2 more machines. So you would want to ideally have 30%, 30%, 30% distribution. But why can't there be like 40, 50, and 10? Or, I don't know, 30, 30, and 39. No, 30, 30, and 40. Yeah. Well, we have a question. Let's go and ask like the person that can answer it. Why is equal distribution of data between machines important when scaling vertically? When scaling vertically in the context of computing or database management, it usually refers to increasing the resources. No, horizontally. I meant horizontally. Stop. Horizontally. Important when scaling horizontally for several reasons. Load balancing. Horizontal scaling involves distributing the workload across multiple machines to handle increasing traffic or data volume. Each equal distribution ensures that no single machine is overwhelmed with more data that it can handle, thus preventing bottlenecks and ensuring efficient resource utilization. By evenly distributing data, you can optimize the performance of your system. Okay, each machine has a balanced workload, which can lead to a faster response times and better overall performance. Okay, fault tolerances. Distributing data evenly reduces the risk of data loss or downtime in case of machine failures. If data is evenly distributed, the failure of one machine will only affect a portion of the data, and the system can continue to operate with the remaining machines. Okay, makes sense. So if you have like 80 20 80 10 10, then the 80% fails, you're kind of screwed. Scalability. Equal distribution makes it easy to add or remove machines from the system as needed. When new machines are added, data can be evenly distributed among them without causing imbalance or disruption to the system. And then we have simplicity of management. Managing systems with evenly distributed data is typically simpler than managing one with unevenly distributed data. It reduces the complexity of data partitioning and rebalancing tasks, making it easier to maintain and scale the system over time. Okay. And then we have replication. The replication method of scaling horizontally creates multiple copies of the same database on multiple machines. Usually, one machine is designated as the primary machine. Okay. And all database changes made on that machine are propagated to all the other database replicas. This ensures that all instances of the database are up to date. Okay. The advantage of this horizontal scaling method is that system availability and fault tolerance is greatly improved. Specifically, if the primary machine has an outage, one of the other existing machines can be promoted to the status of primary machine. And since all machines have same database with the same data set, the system can continue to operate without interruption. In addition, due to the existence of more machines, improved performance can also occur, as data requests can be distributed across multiple machines. Alright. Oh, Ruiviana. I hope I spelled that correctly. Welcome to the stream. Thank you for the follow. We're learning about databases. So if that's something that's interesting to you, well, stick around. But okay, replication. I get sharding. But how does replication? Because okay, you have one machine, let's say that's full of data. It's at 100% capacity. Then you add a second machine. Then you replicate 100% of that data into the second machine. So now the second machine is full as well. How does that work? I don't think it's gonna answer us that question. Okay, well, you know, another question to ask ChatGPT. All right, so why is database replication useful? Isn't it the case that if we have one machine that's at 100% capacity, replicating the data from it onto a second machine doesn't really improve performance, because the second machine will also be at 100% capacity after replication. So spelling errors, just ignore that. I'm just trying to phrase the question correctly. Hey buddy, just found you through YouTube. Oh, you're through YouTube. Holy crap, I think you're the first person who's found me through YouTube. Also doing backend? Oh, that's cool. Well, I'm not actually doing backend anymore. Well, sorta am. I actually went to a job interview and they were like, okay, so you have some holes. Plug these holes, we'll give you a job. So I'm basically plugging these holes, which is mostly in back-end related stuff. So, yeah. But how far along are you on your back-end journey? Like, what have you learned so far? And where are you learning? Is another question that I'm quite interested in. Okay, so database replication serves several purposes beyond simply improving performance. High availability. Replication helps in ensuring high availability of the database. The primary database... Okay, we got that. Fault tolerance, load balancing. Wait, how is load balancing? Replication can be used to distribute read-heavy workloads across multiple servers. While it's true that replicating data onto another server won't reduce the load on the primary server for write operations, it can distribute read operations across multiple servers, therefore thereby improving overall performance. Oh, so there's like even a difference, different kinds of operations, read and write. Well, it makes sense, obviously, but I didn't think about it before. Disaster recovery. Okay, that makes sense. Geographic distribution. Replicating data across multiple locations can reduce latency for users accessing the application. Okay, that also makes sense. Scalability. Okay, so it depends on what kind of goal you're trying to achieve with your database scaling, right? If you're trying to simply make it run faster, then probably vertical scaling is the choice for you, right? Or if you make it run faster, store more data, and so on and so forth. If you're trying to do the things described here, like distribute geographically, improve disaster recovery, provide high availability, and so on and so forth, then horizontal scaling is probably your best choice. Replication serves several other important purposes and make it a valuable tool in database management. Okay. So key differences between horizontal and vertical scaling. While both vertical scaling and horizontal scaling can increase the capacity and optimize the performance of a system, it is important to understand these differences before selecting the right approach for an organization. Okay, so scalability differences. Because vertical scaling focuses on enhancing the storage, and processing capabilities of the machine, there is a limit to how far these enhancements can be taken. This limit is determined by the specifications of the machine being enhanced. There are also limitations in the options provided by cloud providers, meaning that you may only need 10% more resources, but the next available tier may have 50% more resources for 50% more cost. Right now I'm still learning JS syntax, logical operators. For someone like me without previous code experience, I'm enjoying it a lot. Oh yeah, we just finished I think part 3 of JavaScript ourselves today. So, and it was quite a lot of fun. Even with 2 languages under my belt, it's pretty fun. And I enjoy it. I don't know. I think I enjoy it more than I did Python, or maybe it's about the same, because I do know Python as well. But yeah, there's also another creator that I frequent, and he's also learning JavaScript from scratch. So he finds it a little bit more confusing, I guess, than me. I don't know. But yeah, it's been pretty fun. And I found myself in a situation where typically I would get stuck on certain projects or certain exercises when learning Python. But with JavaScript, maybe it's because of all the added experience that I've gained since I learned Python. Or maybe it's just because my brain works with JavaScript better, but I would solve these exercises much better. Been watching your videos to help me a bit sometimes. Oh, that's cool. I wasn't really sure if someone was watching. I was mostly putting them there for storage, to be honest, because Twitch deletes VODs after a week. So it's cool that you're watching. I mean, I'm trying to upload everything related to programming in order and into the playlist so that if people are following along, you know, they can follow along chronologically and not miss things. But yeah, if you're catching streams, typically there's a little bit more stuff here in terms of not in terms of programming per se, but in terms of like me interacting with chat, being able to talk or just discuss something that's a little off topic. We also sometimes just watch videos or something towards the end of the stream or in the beginning of the stream and so on and so forth. So a little bit of that gets cut out to sort of make the content on YouTube a little bit more focused on programming in case there's someone watching just for the programming. I found it was like when I was looking for Codecademy videos, oh, that's cool. I mean, a lot of people don't like Codecademy for some reason, but I don't know. I enjoy it. I got the pro version after trying out the free version, and it's been paying dividends, I'd say. I don't have to go all over the internet and look for different articles or different, I don't know, different tutorials and get like mixed information from one person saying this is the way to do it, and then you go to another article and another person saying this is the way to do it, and everybody who does it the first way is dumb or something. So yeah, I went on a little bit of a tangent. I guess I'm excited someone came from YouTube. So you're at logical operators. Okay. That's like somewhere roughly approaching the middle of the syntax. Like by no means I consider myself like, oh, I've learned JavaScript. No, I probably just learned Java, like the syntax. But yeah, it's cool. Wait till you get to objects and classes. That's the point where it's either gonna be really fun for you, like it was for me, or it'll be a nightmare, like it was for me in Python. But then I kind of found it fun in JavaScript, so who knows. Okay, let's see. Choosing the right skill. Okay, we don't have to go that deep into MongoDB. Okay, so why were we reading about the scaling? Where was I in this article? Oh, there we go. Okay, so for instance, it can be difficult to scale relational databases horizontally. Is the practice of adding more machines to an existing stack in order to spread out the load and allow for more traffic and faster processing. This is often contrasted with vertical scaling, which involves upgrading the hardware of an existing server, usually by adding more RAM and CPU. Okay, this paragraph now makes a bit more sense than it did previously, before reading the other article. Okay, the reason it's difficult to scale a relational database horizontally has to do with the fact that the relational model is designed to ensure consistency, meaning clients querying the same database will always see the latest data. If you were to scale a relational database horizontally across multiple machines, it becomes difficult to ensure consistency since clients may write data to one node and not the others, and there would likely be a delay between the initial write and the time when the other nodes are updated to reflect the changes. Okay. Getting there. Didn't want to steal your attention for... It's fine. It's fine. My brain is dead since it's Monday, and I had a... I wouldn't say rough weekend, but I feel like I had a rough weekend. So I'm really tired today. My brain is barely working. That's why we're just sitting here reading articles, really. So steal my attention away. You know, it's fine. If you have any questions, if you wanna ask something in general, just go ahead. It's absolutely a-okay. And not just today. I guess it's okay in general, any day. Alright, so another limitation presented by RDBMs is that the relational model was designed to manage structured data. Okay. Or data that aligns with predefined data type, or is at least organized in some predetermined way. making it easily sortable and searchable. With the spread of personal computing and the rise of internet in the early 1990s, however, unstructured data such as email messages, photos, videos, etc. became more common. Oh. Okay. As these limitations grew more constricting, developers began looking for alternatives to the traditional relational data model, leading to the growth of popular NoSQL databases. Okay, so from what I gather, NoSQL is basically used for more like, how should I put it? Maybe like content related storage. But then I guess, I don't know, relational databases also have certain data types that are suited for media types or big data. That's one way to do it. The other way to do it is you can just translate those things into bits and store that as well. So, I don't know. So, the label NoSQL itself has a rather fuzzy definition. NoSQL was coined in 1998 by Carlos Strozzi as the name of his then new NoSQL database. 1 second, guys. Okay, I'm back. So the oh my god, my chair is falling apart. So the name was chosen simply because it doesn't use SQL for managing data. The term took a new meaning after 2009 when Johan Oscarsson organized a meetup for developers to discuss the spread of open source distributed and non-relational databases like Cassandra. Voldemort? There's a what? There's a database called Voldemort. Distributed key value storage system. So it's a dictionary automatically replicated over multiple servers, automatically partitioned so each server contains only a subset of the total data. Oh, Horcruxes. Voldemort. That makes sense. Provides tunable consistency. Server failure is handled transparently. Okay. Someone is a big fan of Harry Potter? Dude. Yeah. It's a non-relational database. It does not attempt to satisfy arbitrary relations while satisfying ACID properties. Nor is it an object database that attempts to transparently map object reference graphs. Okay, interesting. Are you a Harry Potter fan? Putting aside all the stuff related to the author, I'm just asking about the books and the movies, separate from the author. Whatever thoughts you may have about the author, they don't apply. So, interestingly, Strozzi's NoSQL database does in fact employ the relational model. Okay. Meaning that the original NoSQL database doesn't fit in the contemporary definition of NoSQL. Oh, so typical. Because NoSQL generally refers to any database management system that doesn't employ the relational model, there are several operational data models associated with the NoSQL concept. Following tables include several such data models, but please note that this is not a comprehensive list. Okay, so we have Redis key value store. Add Voldemort here. Columnar base database. Cassandra, Apache, HBase. Document store. MongoDB and Couchbase. And graph database. Okay. Despite these different underlying data models, most NoSQL databases share several characteristics. For one, NoSQL databases are typically designed to maximize availability at the expense of consistency. In this sense, consistency refers to the idea that any read operation will return the most recent data written to the database. Oh, okay. In a distributed database designed for a strong consistency, any data written to one node will be immediately available to all other nodes. Otherwise, an error will occur. A distributed database designed for strong consistency, any data written to one node will immediately be available to all other nodes. Okay. I don't know what that means, but I get the idea. Conversely, NoSQL databases oftentimes aim for several eventual consistency. This means the newly written data is made available on other nodes in the database eventually, usually in a matter of a few milliseconds, though not necessarily immediately. This has the benefit of improving the availability of one's data. Even though you may not see the very latest data written, you can still view an earlier version of it instead of receiving an error. Relational databases are designed to deal with normalized data that fits neatly into a predetermined schema. In the context of DBMs, normalized data is data that's been organized in a way to eliminate redundancies, meaning that the database takes up as little storage space as possible, while a schema is an outline of how the data in the database is structured. Okay. While NoSQL databases are equipped to handle normalized data, and they are able to sort data with a predefined schema, their respective data models usually allow for far greater flexibility than the rigid structure imposed by relational databases. Because of this, NoSQL databases have a reputation for being a better choice for storing semi-structured and unstructured data. With that in mind, though, because NoSQL databases don't come with a predetermined schema that often means it's up to the database administrator to define how the data should be organized and accessed in whatever way makes the most sense for their application. Okay, but then that presents a different problem where essentially every database manager might have a different idea of how the data should be organized and structured. And that introduces the human factor, which is usually a big problem. Okay, so now that you have some context around what NoSQL databases are and what makes them different from relational databases, let's take a closer look at some of the more widely implemented NoSQL database models. Okay. So we have the key value databases that are also known as key value stores, work by storing and managing associative arrays. Yeah, basically, a dictionary. An associative array, also known as a dictionary or hash table, consists of a collection of key value pairs in which a key serves as a unique identifier to retrieve the associated value. Values can be anything from simple objects like integers or strings to more complex objects like JSON structures. Okay. In contrast to relational databases, which define a data structure made up of tables and rows and columns with predefined data types, key-value databases store data as a single collection without any structure or relation. After connecting to a database server, an application can define a key, for example, meaning of life, and provide a matching value, for example, 42, which can later be retrieved the same way by supplying the key. Okay. A key-value database treats any data held within as an opaque blob. It's up to the application to understand how it's structured. Key-value databases are often described as highly performant, efficient, and scalable. Well, it makes sense because dictionaries are basically the best. They have the best efficiency in terms of all the arrays. Common use cases for key-value databases are caching, message queuing, and session management. All right. Okay, we have a lot of this article left. Let's take a little break, 10 minutes as usual, and we'll continue on after that. So, I'll see you guys in 10 minutes. Okay, and we're back after our little dog petting session. Let's take a look at what else this article has to tell us about databases. Okay, so we have columnar databases, and these are sometimes called column-oriented databases. And they are database systems that store data in columns. Okay, this may seem similar to traditional relational databases, but rather than the grouping columns together into tables, each column is stored in a separate file or region in the system storage. This sounds like relational databases with extra steps, to be honest. The data stored in a columnar database appears in record order, meaning that the first entry in one column is related to the first entry in another column. I need to read that again to understand it. First entry in one column is related to the first entry in other columns. Okay, this design allows queries to only read the columns they need, rather than having to read every row in a table and discard unneeded data after it's been stored in memory. Okay, I will take your word for it. Because data in each column is of the same type, it allows for various storage and read optimization strategies. In particular, many columnar database administrators implement a compression strategy such as run length encoding to minimize the amount of space taken up by a single column. This can have the benefit of speeding up reads since queries need to go over fewer rows. Okay. One drawback with columnar databases, though, is that load performance tends to be slow, since each column must be written separately and data is often kept compressed. Incremental loads, in particular, as well as reads of individual records, can be costly in terms of performance. Column-oriented databases have been around since 1960s. Since the mid-2000s, though, columnar database is such a hard word to pronounce. Columnar databases have become more widely used for data analytics, since the columnar database model lends itself well for fast querying process. They're also seen as advantageous in cases where an application needs to frequently perform aggregate functions, such as finding the average or total sum of data in a column. Okay, so some of these systems are even capable of using SQL queries. So it's not entirely no SQL either. Alright, so we have Apache Cassandra, Apache HBase, and ClickHouse. Alright. Then we have document-oriented databases, or document stores. There are no SQL databases that store data in form of documents. The document stores are a type of key-value store. Each document has a unique identifier, its key, and the document itself serves as the value. Okay. Oh, sneezing coming, maybe. No. Okay. So the difference between these two models is that in a key value database, the data is treated as opaque, and the database doesn't know or care about the data held within. It's up to the application to understand what data is stored. In a document store, however, each document contains some kind of metadata that provides a degree of structure to the data. Document stores often come with an API or query language that allows users to retrieve documents based on the metadata they contain. Okay. They also allow for complex data structures. So somebody created some kind of like somebody looked at some key value databases and they were like, how do I use this? And then they created a document-oriented database, which is essentially the same thing. Okay, they also allow for complex data structures, as you can nest documents within other documents. Unlike relational databases in which the information of a given object may be spread across multiple tables or databases, a document-oriented database can store all the data of a given object in a single document. Okay, document stores typically store data as JSON, BSON, XML, or YAML documents, and some can store binary formats like PDF documents. Some use variant of SQL, full text search, or their own native query language for data retrieval, and others feature more than one query method. Alright. Document-oriented databases have seen an enormous growth in popularity in recent years. Thanks to their flexible schema, they found regular use in e-commerce, blogging, and analytics platforms, as well as content management systems. Document stores are considered highly scalable, with sharding being a common horizontal scaling strategy. Okay. They are also excellent for keeping large amounts of unrelated complex information that varies in structure. And we have finally graph databases. Can be thought of as a subcategory of the document store model, in that they store data in documents and don't insist the data to adhere to a predefined schema. The difference, though, is that graph databases add an extra layer to the document model by highlighting the relationship between individual documents. So we've gone full circle. To better grasp the concept of graph databases, it's important to understand the following terms. Node is a representation of an individual entity tracked by a graph database. It is a more or less equivalent to the concept of a record or row in a relational database, or a document in a document store. For example, in a graph database of music recording artists, a node might represent a single performer or band. Okay. Then we have property, which is irrelevant information related to individual nodes. Building on our recording artist example, some properties might be vocalist, jazz, or platinum selling artist, depending on what the information is relevant to the database. Edge, also known as a graph or relationship, an edge is the representation of how two nodes are related, and is a key concept in graph databases that differentiates them from relational databases and document store. Well, technically, okay, so a graph, what is a graph? Well, that is simply what is an edge? Well, that's just a primary and foreign key relationship, sort of. No? The only difference, I guess, is that edges can be directed or undirected. In an undirected graph, the edges between nodes exist just to show a connection between them. In this case, edges can be thought of as two-way relationships, and there's no implied difference between how one node relates to one another. An indirected graph, edges can have different meanings based on which direction the relationship originates from. In this case, edges are one-way relationships. For example, a directed graph database might specify a relationship from Sammy to the Seaweeds, showing that Sammy produced the album for the group, but might not show an equivalent relationship to the Seaweeds from Seaweeds to Sammy. Okay. So certain operations are much simpler to perform using graph databases because of how they link and group related pieces of information. These databases are commonly used in cases where it's important to be able to gain insight from the relationship between data points, or in applications where the information available to end users is determined by their connection to others, as in a social network. Okay, so they found regular use in fraud detection, recommendation engines, and identity and access management applications. Okay. Well, I guess we have a little bit of a better understanding of databases and relational versus NoSQL databases. So then we have an article in PostgreSQL, also why learn SQL. We're going to skip those. SQL and databases are more important than you think in 2018. It's a bit outdated, so we will skip that. What I am interested in, though, in what am I in what I'm having a stroke. What I am interested in. Oh, it's Flutter, not Fiddle. What is Fiddle? Welcome to SQL Fiddle, an online compiler that lets you write, edit, and execute any SQL query. Choose which language you would like to practice today. Ooh, this is maybe a good practice website for SQL. To provide an online SQL playground to let people learn and improve their SQL skills. Comprehensive platform designed to support your journey in mastering SQL. Whether you're a beginner looking to grasp the basics or an experienced professional refining your skills, the SQL Fiddle provides the tools and resources you need to succeed. Oh, this is pretty good. So, editor. Only users who are logged in can access the AI chat feature. SQL server. Okay. Me no understand what I'm looking into. Create table product. Okay, so product ID, name, description. Sure. Oh, I completely sort of blindsided myself with the fact that you can actually just create a database in SQL using commands. It's not just for querying or retrieving information, it's also for inserting information too. So that's another thing that we're gonna have to tackle probably. Okay, well, we can close that. Kickstarter SQL style guide. Oh my god, so much. Alright, let's take a look. Select. Align all columns to the first column on their own line. Select goes on its own line. Always rename aggregates and function wrapped columns. Okay. Always rename all columns when selecting with table aliases. Okay. Always use as to rename column. Projects.name as project name. Count backings ID as backings count. Bad. Project's name, project's name. Okay, from. Only one table should be in the from. Never use from joins. What is a from join? From KSR.projects as projects. Inner join case are backings. It's backings on backings. Project ID. Projects.id. So this is good for some reason, and this is bad. Project's name is project name. That's the same. Count backings ID is backings ID. This is the same. From as backings. There's two as. Oh, wait, what? Where's the on statement? Alright, this is too much. Too much syntax for my poor brain. Let's continue. Designing relational databases. So this is the next unit, right? Yes. But what I want to do is go back to this unit because we kind of missed it. Okay, so what you'll be learning in Database Basics unit. The goal of this unit is to learn how to create databases using PostgreSQL. Much of the internet is the flow of information. Databases like PostgreSQL store data so you can be displayed on the web. Be able to explain what a database is, differentiate the differences between SQL and NoSQL database, create and manipulate a PostgreSQL table, download PostgreSQL and run a SQL database. It should be an SQL database or a database. Run a SQL database, an SQL database. Oh my god. Okay. Let's take a look. It shouldn't be too long. What is a relational database management system? We kind of went through that in the previous article, right? MySQL, PostgreSQL is an open source SQL database that is not controlled by any corporation. It is typically used for web application development. PostgreSQL shares many of the same advantages of MySQL. It's easy to use, inexpensive, reliable, and has a large community of developers. It also provides some additional features such as foreign key support without requiring complex configuration. The main disadvantage of PostgreSQL is that it can be slower in performance than other databases such as MySQL. It is also slightly less popular than MySQL. Okay, we have Oracle DB. Is for large applications, particularly in the banking industry. Most of the world's top banks run Oracle applications because Oracle offers a powerful combination of technology and comprehensive pre-integrated business applications, including essential functionality built specifically for banks. The main disadvantage of using Oracle is that it's not free to use like its open source competitors and can be quite expensive. Okay, so we have SQL Server. I was pretty confused the fact that there's like SQL, MySQL, then there's SQL Server. There's also SQLite. So what is MySQL? Open source SQL database. It is typically used for, I guess MySQL is database management system. It's not like the SQL itself. The main advantages are it's easy to use, inexpensive, reliable, and has a large community. Okay. Been known to suffer from poor performance when scaling. Open source development has lagged since Oracle has taken control of MySQL, and it does not include some advanced features that developers may be used to. So Oracle now controls SQL. Interesting. SQL Server. Microsoft owns SQL Server. Like Oracle DB, the code is closed-sourced. Large enterprise applications mostly use SQL Server. Microsoft offers a free entry-level version called Express, but can become very expensive as you scale your application. Then we have SQLite, which is a popular open-source SQL database. You can store an entire database in a single file. Yeah, SQLite, that's kind of what I worked with in my previous projects. One of the most significant advantages this provides is that all of the data can be stored locally without having to connect your database to a server. Yep. SQLite is a popular choice for databases in cell phones, PDAs, MP3 players, set-top boxes, and other electronic gadgets. The SQL courses in Codecademy use SQLite. What is a What is a set-top box? What is a set-top box? Set-top box. Oh, it's like a DVD player thing? Or something like that? Okay. Okay. On Codecademy, we use both SQLite and PostgreSQL. While this may sound confusing, don't worry. We want to stress that the basic syntax you will learn can be used in both systems. For example, the syntax to create tables, insert data into those tables, and retrieve data from those tables are all identical. That's one of the nice parts of learning SQL. By learning the fundamentals with one RDBMS, you can easily begin work in another. That being said, let's take a look at some of the more subtle details. So file extensions, when working with databases on Codecademy, take a look at the name of the file you're writing in. If the file ends in SQLite, you're using SQLite database. If the file ends in SQL, you're working with PostgreSQL. Then we also have data types, which we'll learn about data types very early into learning a RDBMS. One thing to note is SQLite and PostgreSQL have slightly different data types. For example, if you want to store text in SQLite database, you'll use the text data type. If you're working with PostgreSQL, you have many more options. You could use varchar, char, or text. Each type has its own subtle differences. This is a good example of PostgreSQL being slightly more robust than SQLite, but the core concepts remaining the same. And then also, yeah, SQLite has built-in tables, I think. As you work your way through more complicated lessons on databases, you'll start to learn how to access built-in tables. For example, if you take our lesson on indexes, you'll learn how to look at the table that the system automatically creates to keep track of what indexes exist. Depending on which RDBM system you're using, the syntax for doing that will be different. Anytime you're writing SQL about the database itself rather than the data, the syntax will likely be unique to the RDBMS you're using. Oh, what a read. Okay, so we did check out NoSQL. Yeah, we went over key value, document, graph, column oriented, and whatnot. There's more SQL. Oh my god, there's so much more SQL to write. Yeah, we didn't really look into creating databases. All right, we'll tackle that next week. Yeah, because boy oh boy. All right, we can set this as done. We kind of skipped database basics, but we'll work with that tomorrow. Because I just do not have the computational power for it today anymore. We can close this. All right, we still have a little bit of time, and I have a good amount of articles sort of just sitting there, waiting to be read. We have like eloquent JavaScript here. Oh, that's an entire book. Never mind, probably not going to do that right now. What else do we have? The JavaScript programming language. This is an hour-long video. Probably not going to do that. This is also an hour and a half. Never mind. Modern JavaScript cheat sheet. Okay, we can take a look at this. Actually, this is also an entire book pretty much. Oh my god. Yep. Alright, I'm not gonna force feed myself programming anymore today. So yeah, that's pretty much it for today, to be honest. I don't think we can tackle anything else. If anyone's been following this thing entirely, is probably brain dead just as much as me. In terms of our roadmap, we're making good progress. We'll tackle database basics tomorrow. And then probably jump into designing relational databases. Might take a look at PostgreSQL. I will sit down and, because I didn't do it on the weekend, I will sit down and sort of remake this roadmap a little bit. Please don't, nope, don't go anywhere. Go back. I will remake this entire roadmap a little bit to better fit into the requirements that I'm supposed to achieve based on the 50 slides that I was provided by my potential future employer. So either tomorrow or the day after, like, there's no rush. We still have quite a few things here to finish before it becomes relevant, because I want to finish these things regardless of whatever the topics that we have to cover for the job are. Yeah. But we're making good progress. In terms of the course itself, it's a little bit of a shame that we won't be able to finish it. We will eventually finish it, but just maybe not anytime soon. Because if we take a look at the path, we're kind of 27% done. By the time we finish, we'll probably be like 35% done. We're fairly close to the exam as well. Like, there's GitHub and there's portfolio project. So we might tackle that, I don't know, at some point. Because eventually, I think, if I get the job, you know, like, I will probably dedicate weekends for programming as well instead of gaming. Because I'm really, I don't know, I'm not into, which is weird because I was very much into the idea of game streaming. But the past couple of weekends doing gaming streaming has been a little bit underwhelming. So, I don't know. I'll think about it. I'll think about what to do.